On July 1st, 2025, a telescope in Chile detected something that shouldn't exist. An object from beyond our solar system, moving at 137,000 miles per hour, on a trajectory that defies natural explanation. NASA called it a comet, but as government shutdowns silenced updates, as critical images from Mars vanished into bureaucratic darkness, and as a Harvard astrophysicist calculated a 40% probability this might be alien technology, a different story emerged. In October, this object will pass behind the sun, hidden from every telescope on Earth, at the exact moment when something could happen that we'll never see. Before we begin tonight's journey, take a moment to like this video and subscribe, but only if you truly enjoy exploring mysteries with us. And I'd love to know where you're tuning in from and what time it is for you right now. It's always fascinating to see listeners joining from every corner of the world. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. Picture a telescope dome in the Chilean Andes, July 1st, 2025. The night is clear, cold, air so thin and dry that stars burn with unusual brightness. Inside the dome, no one is watching. The telescope operates automatically, part of a global network called ATLAS, the Asteroid Terrestrial Impact Last Alert System. Its job is simple: scan the sky, find objects that move, calculate their paths, flag anything that might threaten Earth. On this particular night, the system finds something. A faint smudge of light, barely visible, moving against the background stars. The computer notes its position, its velocity, its direction. Within hours, the data streams to the Minor Planet Center in Massachusetts, where astronomers review observations from telescopes worldwide. They look at the numbers. They look again. Something is wrong with this object. Or rather, something is right with it in a way that shouldn't be possible. The trajectory is hyperbolic. That's the technical term. It means this object isn't orbiting our sun. It's just passing through, moving too fast for the sun's gravity to capture it. It came from somewhere else, from the space between stars, and it's heading back out into that darkness after its brief visit to our neighborhood. This makes it only the third confirmed interstellar object ever detected by humanity. The third visitor from beyond. But this one is different. The official announcement comes quickly. NASA, ESA, observatories around the world all confirm it. Interstellar object, designated 3I Atlas. The I stands for interstellar. The 3 because it's the third one we found. The Atlas because that's the survey that spotted it first. Simple enough. The press releases go out. News articles get written. Rare interstellar comet visits our solar system. Scientists express excitement about this opportunity to study material from another star system. Educational, fascinating, safe. But within days, whispers start. Questions that don't quite fit the neat official narrative. Because when you look closer at 3I Atlas, when you really examine what we're seeing, certain details stand out. Details that make some researchers uncomfortable. Details that NASA seems eager to explain away before the public thinks too hard about them. Let's start with the most obvious problem. The object is huge. When I say huge, I mean by interstellar visitor standards. Our first interstellar guest, Oumuamua, discovered in 2017, was maybe 400 meters long. Picture a large building tumbling through space. The second visitor, 2I Borisov, showed up in 2019, was probably less than a kilometer across. Still impressive, but comfortably comet-sized. 3I Atlas. Early estimates suggested it could be anywhere from 3.5 miles to 12 miles in diameter. Some calculations put it as large as 20 kilometers across. That's not a building. That's not even a mountain. That's the size of a small moon. That's roughly the size of Phobos, one of Mars' moons. An interstellar object that massive? The statistics say we should see thousands of smaller visitors before encountering one this large. Yet here we are, only 3 detections ever, and the third one is by far the biggest. The mass estimates are equally troubling. To resist the forces acting on it, to show the trajectory it shows, 3I Atlas must weigh at least 33 billion tons. That's a conservative estimate, a lower limit. It could be much heavier. For context, that's orders of magnitude more massive than astronomers expected. It's so heavy that when gas and dust stream off its surface, when it's outgassing like a comet should, that outgassing doesn't push it, doesn't change its path. Normal comets get a rocket effect from outgassing. The gas jets out one side, pushes the comet the other direction. We can measure this. We've measured it on countless comets. But 3I Atlas? Nothing. No measurable push. Which means either it's extraordinarily dense, far denser than any comet should be, or something else is going on. Then there's the trajectory itself. Objects in space can arrive from any direction. 3 dimensions. Infinite angles. The plane where Earth and the other planets orbit, the ecliptic, is just one plane among infinite possibilities. Most objects come in tilted relative to this plane. But 3I Atlas? Its orbit aligns with the ecliptic to within about 5 degrees. That's unusually close. The probability of random alignment that precise? Less than 1%. Some scientists call this coincidence. Others note that if you were navigating toward the inner solar system, if you wanted to pass near the planets where life might exist, you'd approach along the ecliptic. That's where everything is. That's where the interesting targets are. And the orbit is retrograde. Moving backward relative to the planets, motion. This combination, aligned with the ecliptic, but going the wrong direction, is exceptionally rare for a natural object. But it's exactly what you'd want if you were deploying probes. The planets would move into your path. You could release small objects that the planets intercept naturally, without needing massive velocity changes. It's elegant, efficient. The kind of trajectory an engineer might design. The direction it came from raises eyebrows too. 3I Atlas approached from Sagittarius, the direction of our galaxy's center, the brightest, most crowded region of the sky, as seen from Earth. This made the object harder to spot early. Against the brilliant background, a faint moving comet is easy to miss. In fact, it was missed for weeks. Pre-discovery images show it was visible as early as June 14th, but nobody noticed until July 1st. By then, it was closer, brighter, undeniable. Some researchers point out that coming from the galactic center region means the object likely originated from the galaxy's thick disk, an older stellar population. Trajectory analysis suggests 3I Atlas could be 7.6 billion years old. That's older than our solar system, older than Earth. It's been traveling through space since before our planet existed. Think about that. This chunk of ice or rock or whatever it is has been wandering the galaxy for billions of years, drifting through the darkness between stars, until finally, in July 2025, it happens to pass through our solar system. What are the odds? Actually, we can calculate the odds. They're not good. An object that size, that old, arriving on that trajectory at this time? Loeb, the Harvard astronomer, who's become famous for suggesting Oumuamua might have been artificial, ran the numbers. He gives 3I Atlas a 4 on a scale of 0 to 10. 0 means definitely natural. 10 means definitely artificial. 4 means about 30 to 40% chance this isn't just a rock. Those aren't small odds. Those are worth investigating seriously odds. But NASA's official position was established quickly. Within days of confirmation, statements went out. It's a comet. Natural interstellar visitor. No threat to Earth. Everything we're seeing is consistent with cometary behavior. Tom Statler, NASA's lead scientist for small bodies, was quoted in multiple outlets. It looks like a comet. It does comet things. The evidence overwhelmingly points to this being a natural body. Simple, clear, reassuring, case closed, or so they wanted us to believe. Except the Hubble Space Telescope images told a more complicated story. When Hubble photographed 3I Atlas in late July, it showed something unusual, a teardrop-shaped cocoon of dust surrounding the nucleus. But the dust was pointing forward, toward the sun, not away from it. Normal comets develop tails that point away from the sun. Solar wind pushes the gas and dust backward. That's basic physics. That's how comets work. Yet here was 3I Atlas, with a forward-facing jet, 10 times longer than it was wide, aimed directly at the star it was approaching. NASA scientists explain this as small icy grains being heated by sunlight, creating an extended source of water vapor. Possible, they said. Unusual, but not unprecedented. A handful of distant comets have shown similar features. A faint tail did eventually appear at the end of August, almost 2 months after discovery. By then, astronomers had been watching the object for weeks. Why did it take so long? Why did the forward jet appear first? These questions didn't get satisfying answers, just reassurances that everything was probably fine, probably natural, probably nothing to worry about. The discovery of 3I Atlas should have been purely exciting. A rare visitor from another star system, a chance to study interstellar material up close, an opportunity to learn about planetary formation in distant solar systems. And for many scientists, it was exactly that. Telescopes around the world aimed at this target. Observation campaigns were organized. Papers were planned. This was good science, important research, the kind of discovery that comes along once in a generation. But lurking beneath the excitement was unease. The object's properties didn't quite fit. The timeline of information release seemed carefully managed. And as the object continued its journey inward, as it approached Mars in early October, as critical observation windows arrived, something strange happened. Information stopped flowing, images disappeared, and the questions people were asking got louder, more insistent, harder to ignore. What is 3I Atlas actually? Where did it really come from? And why does NASA seem so determined to call it a comet before all the evidence is in? The official story is clear and simple. But clear and simple isn't always true. Sometimes the truth is complicated. Sometimes it's uncomfortable. And sometimes, just sometimes, the conspiracy theorists are asking the right questions, even if they don't have all the right answers yet. As 3I Atlas moved closer to the sun, as the best observation opportunities approached, something else happened. The United States government shut down. NASA furloughed over 15,000 employees. Website updates stopped. Press releases halted. And at the exact moment when multiple spacecraft around Mars were positioned to capture the clearest images humanity would ever get of this mysterious visitor, official communication went silent. Convenient timing or something more calculated? We'll explore that question soon. But first, we need to understand exactly what makes 3I Atlas so strange. We need to examine the anomalies one by one and ask ourselves whether 7 unlikely things happening to the same object is coincidence or pattern. Whether we're seeing nature at its weirdest or something else entirely. Something that's been traveling toward us for a very long time with a very specific purpose. When Harvard astrophysicist Avi Loeb compiled data from over 4,000 observations of 3I Atlas, when he looked at reports from 227 observatories spanning 6 continents, he noticed something unsettling. Not one anomaly, not 2. 7 distinct features that each, individually, represent unlikely events. Taken together, they form a pattern that's harder to dismiss as random chance. These aren't wild speculations from fringe theorists. These are documented observations, measurable properties, mathematical probabilities. You can agree or disagree with Loeb's interpretation, but you can't dispute the data itself. Let's walk through each anomaly carefully, one at a time, and you can decide for yourself what they mean. The first anomaly is size, and we've touched on this already, but it's worth examining in detail because the implications are profound. 3I Atlas has a minimum diameter of 5 kilometers. That's the lower bound, the smallest it could possibly be, based on how much sunlight it reflects and how it resists forces acting on it. The upper estimates range much higher, possibly 20 kilometers across. To put that in perspective, Oumuamua, our first interstellar visitor, was roughly 400 meters long. That means 3I Atlas is at least 12 times larger, possibly 50 times larger. Here's why that matters. The distribution of objects in space follows a power law. Small objects are exponentially more common than large ones. For every 1-kilometer asteroid, there are thousands of 100-meter asteroids. For every 10-kilometer asteroid, there are thousands of 1-kilometer asteroids. The pattern holds across the universe. It's fundamental physics, the result of how objects form and break apart over cosmic timescales. Apply this to interstellar objects. If we're detecting them randomly, we should see many small ones before we see a large one. The math is clear. We should have found dozens, maybe hundreds, of Oumuamua-sized visitors before encountering anything as large as 3I Atlas. Yet we've only confirmed 3 interstellar objects total in human history. And the third one is by far the biggest. That's not how probability works. That's not how random sampling works. Either we're incredibly unlucky, in a statistically improbable way, or 3I Atlas isn't a random sample. It's something else. Something that doesn't follow the natural size distribution because it wasn't naturally formed or naturally ejected. Something that's this size for a reason. The mass compounds the problem. To show no acceleration despite massive outgassing, 3I Atlas must weigh at least 33 billion tons. That's not an estimate. That's a minimum required mass based on the forces acting on it and its observed trajectory. It could be much heavier. For a comet, this is absurdly dense. Ice and rock mixed together, even with some metal content, shouldn't produce something this heavy at this size. You'd need almost solid metal, or a hollow structure filled with something very dense, or internal composition unlike any comet we've studied. NASA says it's just an unusually dense comet nucleus. Possible? Yes. Likely? That's another question. The second anomaly is the forward jet. Hubble captured this in late July 2025. The image shows a teardrop-shaped cocoon of material surrounding 3I Atlas. But instead of trailing behind the object, like a normal comet's tail, this glow extends ahead of it, pointing toward the sun. The jet is 10 times longer than it is wide. A narrow stream of reflected sunlight or scattered material, aimed directly at the star the object is approaching. This is backward. Comets are pushed by solar radiation pressure and solar wind. Material ejected from the nucleus gets blown away from the sun, creating the characteristic tail that always points away from the star, regardless of the comet's direction of travel. That's why comet tails can point forward when a comet is leaving the solar system, its tail streaming ahead of it as the comet moves backward relative to its tail. But 3I Atlas shows the opposite configuration: forward-facing jet, minimal backward tail initially. NASA's explanation involves small, icy grains released from the nucleus being heated by sunlight, subliming and creating an extended source of water vapor. They point out this has been observed in a handful of distant comets before. It's unusual but not unique. The geometry can happen under specific conditions. Okay, but why did a normal tail only appear much later, at the end of August? Why was the forward jet the dominant feature for the first 2 months of observation? If this is natural outgassing following standard physics, the sequence is strange. The timeline doesn't match typical cometary evolution, unless the outgassing isn't typical. Unless something about 3I Atlas's composition, or structure, or activity is fundamentally different from normal comets. Or, as some have suggested, unless the forward-facing plume isn't outgassing at all, unless it's exhaust. Rockets fire forward to slow down, to decelerate. An object approaching the inner solar system too fast, wanting to reduce velocity, wanting to be captured into a bound orbit, or position itself carefully, would fire engines in the direction of travel. The exhaust would stream ahead. The plume would look exactly like what Hubble photographed. Speculation? Absolutely, but it fits the observation as well as the natural explanation does. Maybe better. The third anomaly is trajectory alignment. 3I Atlas's orbital plane matches the ecliptic to within 4.89 degrees. The ecliptic is where the planets are, the flat disk where Earth and Mars and Jupiter orbit the Sun. Objects can arrive from any angle in three-dimensional space. The probability that a random interstellar visitor aligns this closely with the plane of the planets less than 1%. It's not impossible. Low probability events happen, but it's another tick mark in the unusual column. What makes this more interesting is that the orbit is retrograde. 3I Atlas is moving backward relative to the planet's motion around the Sun. The combination of ecliptic alignment with retrograde motion is exceptionally rare. Most objects that arrive near the ecliptic are prograde, moving the same direction as the planets, because that's the natural result of how the galaxy rotates and how objects get ejected from their home systems. Retrograde and aligned? That takes special circumstances, or special design. Because if you were planning a flyby of the inner solar system, if you wanted to deploy probes or sensors to multiple planets, a retrograde orbit aligned with the ecliptic is ideal. The planets move into your path. You release small objects and let the planet's orbital motion do the work. Venus passes through your deployment zone, picks up a probe. Mars passes through, picks up another. Jupiter the same. You don't need huge velocity changes. You don't need precise targeting. You just need to be in the right place at the right time, moving the right direction. Elegant orbital mechanics, the kind of solution an engineer would appreciate. The fourth anomaly is the planetary encounter geometry. 3I Atlas will pass relatively close to 3 planets during its journey through the inner solar system: Venus, Mars, and Jupiter. Not extremely close, but close enough that a small object released from 3I Atlas could intercept any of them with minimal thrust. Loeb calculated the delta V required, the change in velocity needed to reach each planet from 3I Atlas's trajectory. For Mars and Venus, it's less than 5 kilometers per second. For Jupiter, same. Those are achievable numbers with chemical rockets, the kind of propulsion we use. Nothing exotic required. What's the probability that a random interstellar trajectory happens to pass near 3 different planets with such low intercept costs? Loeb's team calculated this, considering that the object could have arrived at any time with any trajectory. The probability? 0.005%. That's 5 in 100,000. Essentially, it doesn't happen by chance. Either we're witnessing an extraordinary coincidence, or the trajectory was chosen specifically to enable these encounters. Notice which planet isn't on the list. Earth. 3I Atlas will not pass particularly close to Earth. It'll approach to about 1.8 astronomical units, about 170 million miles. That's farther than Mars ever gets. Why avoid Earth if you're passing near the other terrestrial planets? One interpretation: Earth has too many telescopes, too much attention, too many people watching. If you're studying a solar system subtly, maybe you give the most developed planet a wide berth. Observe from a distance. Don't attract unnecessary scrutiny. The fifth anomaly is the lack of non-gravitational acceleration despite massive outgassing. This is where things get technically interesting. Oumuamua, our first interstellar visitor, showed mysterious acceleration as it left the solar system. No visible tail or coma, but it sped up more than gravity alone could explain. Scientists proposed various mechanisms: invisible hydrogen outgassing, nitrogen ice sublimation. Other exotic explanations? The mystery was that it accelerated without visible propulsion. 3I Atlas shows the opposite problem. It's outgassing prodigiously. Water vapor is pouring off this object at rates described as like a fire hose. Observations confirm hydroxyl radicals, the chemical fingerprint of water breaking down in sunlight. The activity is intense, visible, exactly what you'd expect from a comet this size, heating up as it approaches the sun. Yet there's no measurable, non-gravitational acceleration. The trajectory follows pure Keplerian motion, gravity alone, as if the outgassing isn't pushing the object at all. For a normal comet, outgassing creates thrust. Gas jets out one side. Momentum conservation pushes the comet the opposite direction. We measure this on every active comet we study. But 3I Atlas? Nothing. The only explanation that makes sense is extreme mass. The object is so heavy that the outgassing forces can't budge it. Those 33 billion tons we mentioned earlier? That's the minimum mass required to resist these forces. It could be heavier, much heavier. At that mass, at that density, this isn't a normal comet. It's something else wearing a comet's disguise. Or it's compensating somehow, using propulsion to maintain a precise trajectory, despite natural forces trying to perturb it. Active navigation, subtle but effective. The sixth anomaly is the galactic origin and age. 3I Atlas came from the direction of Sagittarius, which points toward the galaxy's central bulge, the oldest stellar populations, the thick disk where ancient stars reside. Trajectory reconstruction suggests the object's age could be 7.6 billion years. That's 3 billion years older than our solar system, older than Earth, older than the Sun. How does ice survive 7 billion years in interstellar space? Cosmic rays slowly erode surfaces. Micrometeorite impacts chip away at structures. Radiation heats and sublimates volatile materials. Over millions of years, these effects are manageable. Over billions? Ice shouldn't survive. Rock, maybe. Metal, definitely. But a pristine, icy comet, still outgassing vigorously after 7 billion years of exposure? That requires explanation. Either it's been dormant, frozen solid, never activated until now, Or it's protected somehow, shielded. Or it's not primarily ice at all. The chemistry we're seeing could be surface coating, exterior material designed to look natural while concealing something else underneath. The seventh anomaly is the most speculative but statistically fascinating: the WOW signal connection. On August 15th, 1977, the Big Ear radio telescope at Ohio State University detected a powerful narrowband signal at 1,420.456 megahertz, right on the hydrogen line. The signal lasted 72 seconds. Astronomer Jerry Amons circled it on the computer printout and wrote "WOW" in the margin. The signal never repeated. Its origin: Sagittarius constellation. The mystery has endured for 48 years. Loeb calculated where 3I Atlas was on August 15th, 1977. Answer: about 600 astronomical units from Earth, roughly 55 billion miles out, in the direction of Sagittarius. The angular separation between the WOW signal's origin and 3I Atlas's calculated position at that time: approximately 9 degrees. The probability of this alignment by pure chance: 0.6%. If the WOW signal came from 3I Atlas, the required transmitter power would be between 0.5 gigawatt and 2 gigawatts, based on the detected intensity. That's the output of a typical nuclear reactor. Significant power, but not impossible. Not even particularly advanced. We could build a transmitter that powerful if we wanted to. So the scenario would be: in 1977, an object 600 astronomical units away transmits a brief, powerful signal toward Earth. We detect it. We're listening. We hear. The signal stops. Over the next 48 years, that object travels inward, taking decades to cross the enormous distance between stars. In 2025, it arrives in the inner solar system, approaching Mars, Venus, Jupiter, studying us, investigating the civilization that heard its ping. Is this what happened? Probably not. The correlation is weak, the evidence circumstantial, but it's another statistical unlikelihood added to the pile. Another coincidence that requires explanation. Another piece of a puzzle that doesn't quite form a coherent picture yet, but hints at something beneath the surface. 7 anomalies. 7 unlikely features. Each one individually explainable as natural variation. Unusual but possible combinations of ordinary physics. But all 7 in the same object? All 7 at the same time? The probability drops with each addition. Multiply the individual likelihoods together, and you get a number approaching 0. Not 0, never 0. But low enough that Avi Loeb gives 3I Atlas a 4 on his scale of 0 to 10. Low enough that serious scientists are asking uncomfortable questions. Low enough that NASA's blanket assurances feel premature, rushed, more like narrative control than scientific assessment. These are the anomalies. The documented, measurable, undeniable features that make 3I Atlas more than just another comet. The question is what they mean. Natural processes pushed to their limits, or something else entirely? Something we're not quite ready to acknowledge, but can't quite dismiss either? The answer might depend less on the data itself and more on who controls the information, who decides what we see, and what happened when the best observation opportunity arrived, just as government shutdown plunged NASA into darkness. October 3rd, 2025. A date that should have answered questions. Instead, it raised more. 3I Atlas would pass within 29 million kilometers of Mars, its closest approach to any planet in our solar system. Not close by planetary standards, but close enough. Close enough for the armada of spacecraft orbiting Mars to turn their instruments toward this visitor. close enough for cameras designed to photograph the Martian surface, to photograph something far stranger. Close enough that we might finally see what 3I Atlas actually is, not as a distant smudge of light, but as a resolved object with shape and structure and surface features that would tell us whether it's ice or rock or something else entirely. The preparations began weeks in advance. NASA's Mars Reconnaissance Orbiter carries HiRISE, the High-Resolution Imaging Science Experiment, a camera so powerful it can spot objects the size of a dinner table on the Martian surface from orbit. From Mars's distance to 3I Atlas, HiRISE could resolve features about 30 kilometers across on the visitor's surface. Not quite enough to see fine detail, but enough to determine true size, approximate shape, whether it's a single solid body or a loose cluster of fragments. Enough to settle basic questions that had remained frustratingly uncertain since discovery. The European Space Agency had 2 orbiters ready. Mars Express, carrying the high-resolution stereo camera and several spectrometers, could capture color images and composition data. The Trace Gas Orbiter, equipped with CASIS and the Nomad spectrometer, would analyze the chemistry of whatever gas surrounded 3I Atlas, determining precisely what it was shedding as it heated. China's Tianwen-1 orbiter would observe with its moderate resolution camera. The UAE's Hope orbiter would point its infrared and ultraviolet spectrometers at the target. Even the Perseverance rover, on Mars's surface, with its navigation cameras, might glimpse the object as it crossed the Martian night sky. This was it. The moment astronomers had been anticipating since July. Multiple spacecraft, multiple instruments, multiple viewing angles, all focused on the same target at the same time. Whatever data emerged from October 3rd would either confirm NASA's assessment that 3I Atlas is a normal comet or raise serious doubts that would demand explanation. The astronomy community was ready. Social media buzzed with anticipation. Amateur astronomers planned their own observations once 3I Atlas emerged from behind Mars. This would be the clearest view humanity ever gets of an interstellar visitor. Possibly the clearest we'll get for decades, until better detection systems and faster spacecraft allow us to intercept such objects rather than just photograph them from a distance. And then, 2 days before the flyby, the United States government shut down. October 1st, 2025. Federal funding lapsed. Negotiations in Congress had failed. The government entered one of its periodic shutdowns, the kind that happens every few years when political parties can't agree on budget priorities. NASA, like all federal agencies, was affected. Over 15,000 employees furloughed. Non-essential operations ceased. Website updates stopped. The NASA.gov homepage displayed a message. Due to the lapse in federal government funding, this website is not being updated. Social media accounts went silent. Press releases halted. Communications teams, data processing specialists, public affairs officers, all sent home. The timing seemed unfortunate. 2 days before the most significant observation opportunity of 3I Atlas's entire transit through our solar system, NASA's public-facing operations went dark. But here's the thing about spacecraft. They don't need humans to operate moment by moment. Mars Reconnaissance Orbiter doesn't stop taking pictures because Congress can't pass a budget. The cameras are programmed. The commands are uploaded in advance. The observations happen automatically. What requires humans is processing the data, analyzing it, deciding what it means, and releasing it to the public. That's what stopped. NASA initially indicated that processing the Mars flyby data would take several days under normal circumstances. Standard procedure. Raw images come down from the spacecraft. Engineers check for transmission errors. Scientists calibrate the instruments. Photogrammetrists correct for geometric distortions. Only then does clean data emerge, ready for scientific analysis and public release. During a government shutdown, with most staff furloughed, this process would naturally take longer. Everyone understood. Be patient. The data will come eventually. But then something strange happened. On October 4th, just 24 hours after the Mars flyby, select mainstream media outlets received preliminary briefings from NASA officials. Not images, not technical reports, not calibrated data, just verbal assurances. The message was consistent across outlets. 3I Atlas appears to be a regular comet. Nothing unusual detected. Everything consistent with natural body. No cause for concern. How did they know? The detailed Mars orbiter images supposedly took days to process. Yet conclusions were drawn in 24 hours during a shutdown when most analysts were furloughed. Who made this determination? Based on what data? The questions arose immediately on social media, in astronomy forums, among independent researchers who noticed the timeline didn't make sense. If you're going to rush preliminary conclusions before proper analysis, that suggests either you're seeing exactly what you expected and don't need detailed study, or you're trying to control the narrative before independent analysis can complicate the story. The images themselves remained absent. Days passed, a week. Still nothing official from HiRISE, from Mars Express, from Trace Gas Orbiter. NASA's multimedia page, which normally hosts raw images from Mars missions within hours or days of acquisition, showed nothing related to October 3rd observations of 3I Atlas. The European Space Agency, which should be unaffected by U.S. government shutdowns, also remained silent. No press releases, no images, no preliminary reports. Just quiet. What did emerge were images from Perseverance rover. On October 4th, the rover's navigation cameras captured something streaking across the Martian night sky. Raw images, automatically uploaded to NASA's public database as part of standard operating procedure that continues regardless of shutdown. These images showed an elongated streak, motion blurred, moving against the background stars. Initially, many assumed this was 3I Atlas. Social media erupted. The images were analyzed, enhanced, debated. The object looked cigar-shaped, unusual, exactly the kind of morphology that would support the more exotic hypotheses about 3I Atlas's nature. But then confusion. Some analysts suggested the images might show Phobos, one of Mars's moons, not 3I Atlas at all. Phobos orbits close to Mars, moves quickly across the Martian sky, would appear elongated in a motion-blurred exposure. Without official confirmation from NASA about what the images actually showed, the debate spiraled. Was it the interstellar visitor or just a moon? The images remained ambiguously labeled on NASA's database, filed under Perseverance's routine observations, with no special annotation indicating their significance. Amateur astrophotographer Simeon Schmaus took matters into his own hands. He downloaded the raw Perseverance images, stacked multiple frames, applied enhancement algorithms to pull out faint details obscured by noise. His processed version showed a dim smudge where 3I Atlas should have been based on trajectory predictions. But the resolution was too low for conclusions. You could see something was there, but not what it was. Not its shape, not its structure. Just a presence, a ghost in the Martian sky. Meanwhile, where were the HiRISE images? Mars Reconnaissance Orbiter data typically releases within days for high-interest targets, sometimes within hours if the science team is eager to share findings. This was certainly a high-interest target, arguably the highest interest target MRO had ever observed. Yet weeks passed with nothing. The official explanation, when anyone bothered to give one, was that the government shutdown had disrupted normal operations. Data processing teams were furloughed. Analysis couldn't proceed. Be patient. But the European Space Agency operates independently. Their funding comes from European governments, not US Congress. Their staff weren't furloughed. Their data pipelines weren't affected by Washington politics. Mars Express and Trace Gas Orbiter should have released their observations on normal timelines. They didn't. Trace Gas Orbiter did publish one image, captured on October 3rd, showing 3I Atlas as a small, indistinct blob against space. But the image was oddly unclear, taken from an oblique angle, showing far less detail than the instruments should be capable of at that distance. It felt like a token release, something to point to and say, yes, we observed it, without actually revealing anything useful. This is where patterns become visible to those watching closely. Space researcher Pavel Zlotnik wrote an analysis titled The Silence After Mars, describing what he calls the information playbook. How agencies handle findings that don't fit comfortable categories. Stage 1. Collect the data. Stage 2. Embargo and internal review. Stage 3. Prepare the narrative. Stage 4. Controlled release with interpretation already framed. He suggested we were watching Stage 2 in real time. If any captured imagery appeared ambiguous, if shapes didn't look quite right, if structures seemed artificial or impossible, automatic protocols would trigger. Hold the images. Convene internal review. Cross-agency verification. Make absolutely certain you understand what you're seeing before letting the public freak out over something that might have innocent explanation. Even without deliberate cover-up, bureaucracy alone creates this pattern. Ambiguous data means meetings, committees, peer review, consultation with experts across multiple agencies. These processes take time. Add a government shutdown that scatters personnel and disrupts communication, and delays extend further. From the inside, it's just standard cautious science. From the outside, it looks like stonewalling, like information is being controlled, doled out carefully, with inconvenient details suppressed. The practical effect is the same regardless of intent. A vacuum of information, right when information matters most. Nature abhors a vacuum. So does the internet. In the absence of official data, speculation flourished. Every blurry Perseverance image was analyzed to death. Every comment from any scientist was parsed for hidden meaning. Conspiracy theories multiplied. Some claimed the Mars images showed a massive artificial structure, carefully being hidden from public view. Others insisted the images proved nothing unusual, and the whole controversy was manufactured by attention-seeking researchers. Most people just wanted to see the actual images and make up their own minds. But the images weren't coming. There's historical precedent for this kind of information management. In 1960, the Brookings Institution published a study for NASA examining the implications of space exploration. One section addressed potential discovery of extraterrestrial artifacts. The report recommended careful management of such information if discovered, noting that previous civilizations had sometimes disintegrated when confronted with unfamiliar societies. The suggestion was clear. If you find something paradigm-shifting, don't just tweet it out. Prepare. Consider implications. Control the narrative so public reaction doesn't spiral into panic or social disruption. Has NASA ever implemented these protocols? Officially, they're outdated recommendations, not current policy. Unofficially, institutional memory persists. the logic remains sound. If you genuinely don't know what you're looking at, if the implications could be significant, you verify thoroughly before announcing. You consult across agencies. You prepare explanatory materials. You coordinate internationally so the message is consistent. By the time the public learns anything, the interpretation is already settled. The uncertainty is hidden. The confusion is erased. You get a clean story. Here's what we found. Here's what it means. Everything is fine. This isn't necessarily malicious. It could be responsible caution. But it means we never see the raw confusion, the initial uncertainty. The moment when scientists look at data and say, "I don't know what this is." We only get the polished conclusion after internal debate settles. And if that conclusion is nothing to worry about, just a comet. But the path to that conclusion involved dismissing alternative interpretations too quickly, or suppressing ambiguous images that didn't fit the preferred narrative. We'd never know. The process is opaque by design. Congresswoman Anna Paulina Luna tried to inject some momentum. In late July, before the flyby, she'd contacted Avi Loeb for a briefing on 3I Atlas. Afterward, she wrote a letter to NASA leadership proposing they use the Juno spacecraft, currently near Jupiter, to study the object more closely. A trajectory adjustment would be required, but it was technically feasible. A once-in-a-lifetime opportunity to get close-up data on an interstellar visitor. Her letter described the viral interest from the public, particularly Joe Rogan's audience and other podcast listeners who were following the story intensely. People wanted to know. NASA had the tools. Why not use them? The proposal went nowhere, or at least nowhere public. Mission priorities, fuel considerations, competing scientific objectives, the usual bureaucratic obstacles that prevent decisive action. Meanwhile, 3I Atlas continued its journey, and the window for interception closed. The data from Mars orbit, if it showed anything significant, remained locked away in agency servers or undergoing endless review. And the object itself approached the next critical moment, the moment when it would pass behind the sun, hidden from every telescope on Earth, at precisely the time when something could happen that we'd never witnessed directly. The perihelion passage, the hidden moment, the perfect opportunity for whatever might occur out of sight. There's a moment in every comet's journey when everything changes, when the cold ice that survived for millennia in the frozen darkness suddenly feels the full force of stellar radiation, when surface temperatures soar, when volatiles boil away, when structural integrity faces its ultimate test. This moment is called perihelion, the point of closest approach to the sun. And for 3I Atlas, that moment arrives on October 29th, 2025. 1.4 astronomical units from the sun, about 130 million miles, just inside the orbit of Mars. For context, Earth orbits at 1 astronomical unit, so 3I Atlas will be slightly farther from the sun than we are, but not by much. Close enough that solar radiation intensifies to levels the object hasn't experienced during its billions of years wandering through interstellar space. Close enough that any ice on its surface will sublimate rapidly, that structural weaknesses will reveal themselves, that the object's true nature will face examination by the most demanding judge imaginable: physics itself. Comets often don't survive perihelion intact. The archives are full of objects that approached the sun and simply vanished, torn apart by thermal stress or tidal forces, disintegrating into clouds of debris that slowly disperse. Comet Shoemaker Levy 9, fragmented spectacularly before it even reached the sun, pulled apart by Jupiter's gravity. Comet Ison in 2013 was expected to put on a magnificent show at perihelion, but instead disintegrated. disappointing astronomers who'd hoped to study it for months afterward. The sun is not gentle with visitors. It tests them. Most fail. Will 3I Atlas survive? Based on its apparent mass, its structural integrity so far, probably yes. It's large enough, dense enough, that complete disintegration seems unlikely. But survival doesn't mean unchanged. Perihelion could fragment it into several large pieces, could trigger massive outgassing that dramatically brightens the object, could alter its spin rate or orientation, could reveal internal structures if any surface layers crack away. This is the stress test, the moment of revelation, when we learn what 3I Atlas is actually made of. Except we won't be watching when it happens. The geometry is cruel from an observational standpoint. On October 29th, 3I Atlas will be on the opposite side of the sun from Earth, directly behind our star, as viewed from our planet. The sun's glare will block all telescopes on Earth from seeing anything. You can't point a telescope at the sun and expect to see a dim comet right next to the solar disk. The brightness difference is too extreme. You damage the instrument before detecting anything useful. Space telescopes fare slightly better, but still face enormous challenges. The solar glare extends far beyond the sun's physical disk. Scattered light fills a large region of sky around our star. 3I Atlas will be hidden in that glare, invisible, for weeks. This blackout period is not brief. The object will approach perihelion in late October, pass through it on the 29th, and not emerge from solar glare until early December. More than a month of blindness right when the most interesting things might happen. By the time 3I Atlas becomes visible again, whatever occurred at perihelion will be over. We'll see only the aftermath, the changed trajectory, the new brightness, the altered structure. We won't witness the moment itself. Avi Loeb has pointed this out repeatedly in his writings. The timing could be intentional. If you wanted to do something unobserved, this is exactly when you do it. Hidden behind the sun, shielded from Earth-based observation, with weeks to act before emerging where telescopes can see you again. For a natural comet, the timing is coincidental, meaningless. Comets don't choose their orbits. They follow the paths physics dictates. But for an artificial object, for a probe or spacecraft, following a planned trajectory, the hidden perihelion offers perfect cover for maneuvers that shouldn't be witnessed. What could happen during perihelion? Let's explore the scenarios, from most conventional to most unsettling. Scenario 1. Natural breakup. Thermal stress fractures 3I Atlas into multiple fragments. This is common. When we observe the object in December, we'll see several pieces where there was one, all following slightly divergent trajectories. Spectroscopic analysis reveals ordinary cometary composition, water ice, and rocky dust. The mystery resolves. 3I Atlas was just an unusually large comet that didn't survive its close encounter with the sun. All the anomalies were natural variations, statistical outliers that seemed significant in isolation but mean nothing in aggregate. Case closed. Loeb's scale rating drops to 0 or 1. Everyone moves on. Scenario 2. Natural survival with increased activity. 3I Atlas passes through perihelion intact, but dramatically more active. Massive outgassing. Bright expanding coma. Long spectacular tail streaming behind it. When it emerges in December, it's a beautiful comet, easily visible to backyard telescopes, a gift to amateur astronomers worldwide. The increased activity is exactly what you'd expect from a comet heating up. The forward jet reverses, pointing properly away from the sun now. All the earlier oddities were just pre-perihelion quirks that resolved into normal behavior once the object got truly warm. NASA was right. Natural comet, nothing more. Rating drops to 1 or 2. Scenario 3. Anomalous trajectory change. When 3I Atlas emerges from solar glare, it's not where predictions say it should be. The trajectory has altered. Not by much, but measurably. Either extreme outgassing provided unexpected thrust, pushing the object in some direction, or something fired. An engine. A propulsion system. Orbital mechanics are precise. You can predict comet trajectories with extraordinary accuracy based on gravity alone. Non-gravitational forces like outgassing are detectable and can be accounted for if you see the outgassing. But if trajectory changes without visible cause, without enough outgassing to explain the magnitude of change, then you're looking at something else. Active propulsion, controlled navigation. The Loeb scale rating jumps to 7 or 8. Now you need serious follow-up. Now every telescope available points at this object. Now the questions get uncomfortable. This is where the Oberth maneuver becomes relevant. It's a technique from orbital mechanics named after Hermann Oberth, rocket pioneer. The principle is simple but profound. Rocket burns are more effective when you're moving fast. If you fire an engine when you're at perihelion, moving at maximum velocity as you whip around the sun's gravity amplifies the effect. You get more change in orbital energy for the same fuel expenditure. Every space agency uses this. It's how we send probes to the outer planets. It's how we achieve trajectories that would otherwise be impossible. Now imagine you're traveling between stars. You arrive at a new solar system, moving very fast, too fast to be captured naturally by the star's gravity. You're on a hyperbolic trajectory, passing through and leaving, unless you do something. The solution: a reverse Oberth maneuver. Fire your engines forward, slowing down at perihelion when the effect is maximized. If you do this correctly, with enough thrust at exactly the right moment, you can convert your hyperbolic escape trajectory into a bound elliptical orbit. You capture yourself into the solar system. You become a permanent resident rather than a visitor. 3I Atlas's trajectory allows exactly this. The geometry is perfect. An object approaching perihelion on this path, if it wanted to break and enter a bound orbit, would fire engines during the hidden period behind the sun. By the time it emerges in December, the trajectory has changed from hyperbolic to elliptical, but the burn happened weeks ago, unobserved. You'd detect the trajectory change, but not witness the propulsion event itself. You'd know something happened, but couldn't prove it was artificial, versus some extreme natural outgassing event that coincidentally occurred during the blackout period. Or consider a variant, not the main object changing trajectory, but smaller objects being released. Mini probes. Loeb's mothership hypothesis. 3I Atlas doesn't slow down. It continues on its hyperbolic path, leaving the solar system forever. But during perihelion, hidden behind the sun, it releases dozens or hundreds of small spacecraft. Each one fires its own engines, performs its own Oberth maneuver, enters its own orbit. Some are aimed at Earth, some at Venus, some at Mars. The calculations Loeb published show this is feasible with modest thrust. The delta V required to intercept each planet from 3I Atlas's perihelion position is just a few kilometers per second, achievable with chemical rockets. Nothing exotic needed. The beauty of the retrograde trajectory becomes apparent here. The planets are moving one direction. The mini-probes are released moving the opposite direction. Over the following weeks and months, the planets literally run into the probes. Like standing on a highway overpass, dropping packages onto cars below. You don't need precise targeting. You just need to be in approximately the right place. The relative velocity does the rest. A probe intended for Earth would be released with specific velocity and direction. Several weeks later, Earth moves through that region of space and the probe is there, waiting. Intercept achieved. No one saw the deployment. No one tracked the small dark object crossing millions of miles. It's just suddenly there, approaching Earth by the time anyone notices. This sounds like science fiction until you remember we do similar things. Spacecraft regularly use gravity assists, planetary flybys, Earth maneuvers. The physics is routine. The only question is whether 3I Atlas has the capability, and whether anyone intended for this to happen were not completely blind during perihelion. Some instruments might catch glimpses. Parker's solar probe orbits closer to the Sun than any spacecraft ever built, skimming through the corona, designed to study the solar wind and magnetic fields. It's not optimized for comet observation, but it's in the neighborhood. If 3I Atlas does something dramatic, Parker might see. SOHO, the Solar and Heliospheric Observatory, watches the Sun continuously, monitoring for coronal mass ejections and solar flares. Its coronagraphs can detect comets that pass near the Sun. Dozens of sun-grazing comets have been discovered in SOHO data, often by amateur astronomers reviewing publicly released images. If 3I Atlas brightens significantly, or fragments during perihelion, SOHO might capture it. The stereo spacecraft, positioned at different angles relative to Earth's orbit, can triangulate objects near the Sun, providing three-dimensional positioning that single viewpoints can't achieve. Between these instruments, we might piece together what happens at perihelion, but the observations will be peripheral, incomplete, not the detailed monitoring we'd get from dedicated telescopes tracking the object continuously. We'll have hints, not proof, suggestions, not certainty. Radio telescopes will be listening. The Deep Space Network, NASA's collection of giant antennas used to communicate with spacecraft throughout the solar system, constantly monitors radio frequencies. If 3I Atlas transmits, if it sends signals to deployed probes or back toward its origin star, we might detect them. The Galileo Project telescopes are also listening, specifically hoping to catch any artificial transmissions during this critical period. So far, 3I Atlas has been silent. No radio emissions detected. But silence doesn't mean absence. It could be listening rather than transmitting, or using communication methods we don't recognize, or simply maintaining operational security. No unnecessary chatter that might reveal its nature. Then comes December, the re-emergence. 3I Atlas clears the solar glare and becomes visible to Earth-based telescopes again. This is when we'll know. Within days, probably hours, observations will pour in from around the world. Professional observatories have already scheduled time. Amateur astronomers are ready. Everyone with a capable telescope will be looking. The data will be immediate, public, uncontrolled. NASA can't embargo thousands of independent observers. If 3I Atlas looks different, if its trajectory has changed, if multiple objects now exist where there was one, we'll see it. Compare to predictions. The trajectory is calculated with extraordinary precision. We know where 3I Atlas should be in December based on gravity alone, accounting for solar radiation pressure and expected outgassing. Any deviation means something happened. Measure the brightness, compare to models, see if it's brighter, dimmer, or unchanged. Look for fragments, count the objects. If 3I Atlas broke apart naturally, we should see pieces with similar compositions following related trajectories. If something deployed, the objects will be separate, possibly on different orbital paths. possibly showing different spectral characteristics. The December observations will also search for anything new in Earth's vicinity. If mini probes were released during perihelion and are now approaching our planet, they'd be detectable by asteroid surveys. Atlas, the same system that discovered 3I Atlas, scans the sky every night looking for moving objects. Anything large enough and close enough will show up. The question is whether probes would be designed to be that obvious or whether they'd be small enough, dark enough, to slip past our detection networks until they wanted to be found. And what if nothing unusual appears in December? What if 3I Atlas emerges looking exactly as predicted, on precisely the expected trajectory, showing normal cometary activity and nothing more? Does that prove it's natural? Or does it prove the designers are good at camouflage, that whatever happened at perihelion was subtle enough to avoid detection, that the mission continues in ways we haven't imagined yet? The conspiracy mind never settles. Evidence of absence isn't absence of evidence. Silence can mean nothing happened, or it can mean everything happened exactly as planned, and we're simply not sophisticated enough to notice. We're counting down to perihelion now, days away. The object approaches the sun, heating, outgassing, following its predetermined path. Whether that path was determined billions of years ago by random gravitational interactions in a distant star system, or whether it was calculated more recently by intelligence we can barely imagine, we'll have our best chance at answers in December. Not certainty. Science rarely offers certainty, but more data, better observations, harder questions, and hopefully, eventually, truth. Abraham Loeb is not some fringe researcher shouting from the margins. He's a Harvard astrophysicist, former chair of Harvard's astronomy department from 2011 to 2020, director of the Institute for Theory and Computation at the Harvard-Smithsonian Center for Astrophysics, founding director of Harvard's Black Hole Initiative, former member of the President's Council of Advisors on Science and Technology. He's published over 800 papers in peer-reviewed journals. He's one of the most cited astronomers alive. By every conventional measure, he's part of the scientific establishment, credentialed and accomplished. So why do his colleagues call his theories about 3I Atlas absolute nonsense? Why does Oxford astrophysicist Chris Lintott describe Loeb's suggestions as insulting to the serious work being done to understand this object? Why has the scientific community, which usually debates ideas with professional courtesy even when disagreeing, responded to Loeb's hypothesis about potential alien technology with something approaching fury? The tension isn't about his credentials. It's about what he's willing to say out loud. Loeb looks at anomalous data and states plainly that one possible explanation is artificial origin. That maybe, possibly, we're looking at technology rather than nature. Most scientists refuse to go there, not because they have proof it's wrong, but because saying aliens out loud damages credibility, invites mockery, associates you with conspiracy theorists and UFO enthusiasts. Better to propose increasingly elaborate natural explanations, no matter how unlikely, than to suggest the straightforward interpretation that an object showing technological signatures might actually be technology. This philosophical divide has roots going back years before 3I Atlas appeared. It started with Oumuamua, the first confirmed interstellar visitor, discovered in October 2017. That object was strange from the beginning, highly elongated, maybe 10 times longer than it was wide, tumbling through space with an 8-hour rotation period, accelerating as it left the solar system, despite showing no visible tail or coma. The acceleration was small, but measurable, more than gravity alone could explain, suggesting something was pushing it. Normal comets accelerate when gas jets out from the warming surface, but Oumuamua showed no gas. The Spitzer Space Telescope looked for organic molecules, for carbon-based compounds, for any sign of the material that should surround an outgassing comet. Found nothing. No tail, no coma, no evidence of the very mechanism that supposedly explained the acceleration. Yet the object was definitely accelerating. In 2018, Loeb and his colleague, Shmuel Bialy, published a paper in Astrophysical Journal Letters suggesting one possibility. Oumuamua could be a light sail, a thin artificial structure pushed by solar radiation pressure. The math worked. A sufficiently thin sheet, perhaps a millimeter or less, made of reflective material, would experience significant acceleration from sunlight alone. This would explain the movement without requiring outgassing. Would explain the elongated shape if you were seeing the sail edge on. Would explain the tumbling motion as the sail rotated. The paper was rigorous. Presented as hypothesis, not conclusion. Showed the calculations. Suggested observational tests that could confirm or refute the idea. The response was immediate and brutal. Headlines around the world. Harvard scientist claims alien spaceship visited solar system. Never mind that Loeb claimed no such thing. He proposed it as one possibility among several, worth investigating. But nuance doesn't survive media translation. Within days, scientists were lining up to denounce the idea. Absolute nonsense. Publicity stunt. Irresponsible speculation that undermines serious astronomy. The backlash revealed something about scientific culture that makes many researchers uncomfortable. There's a taboo, an unspoken rule. You don't seriously consider artificial explanations for cosmic phenomena, even when those explanations fit the data as well as, or better than natural ones. Meanwhile, the natural explanations for Oumuamua's acceleration grew increasingly exotic. Hydrogen icebergs, frozen molecular hydrogen subliming invisibly, providing thrust without visible gas. Possible in theory, but requiring very specific formation conditions that we've never observed. Nitrogen ice chunks, solid nitrogen like the surface of Pluto, reflective enough to explain the brightness, volatile enough to sublimate and provide thrust. Again, possible, but requiring special pleading. Each natural explanation had problems. Each required unlikely conditions or unobserved mechanisms. But each was preferable to saying the word alien in a peer-reviewed context. The controversy never resolved. Oumuamua left the solar system. It's gone now, beyond the reach of our telescopes, never to return. We'll never get another chance to study it. The mystery remains. Some papers conclude it was probably a comet with unusual properties. Others find problems with every natural explanation proposed. There's no consensus, just an uneasy truce where people agree to disagree and stop arguing about it in public. Then 3I Atlas arrived, and the whole debate reignited. This time, Loeb was ready with a framework. He proposed the Loeb scale, a 0 to 10 rating system for interstellar objects. 0 means definitely natural, just rock or ice following physical laws. 10 means definitely artificial, showing unambiguous technological signatures like controlled maneuvers or radio transmissions. Everything in between represents varying degrees of uncertainty. The scale provides a way to discuss probability without forcing binary conclusions. You don't have to say it's definitely alien or definitely natural. You can say it rates a 4, meaning 30 to 40% chance of technological origin, acknowledging uncertainty while taking the possibility seriously. For 3I Atlas, Loeb assigns a rating of 4 based on the combination of anomalies. Individually, each oddity could be natural. Collectively, they push the probability upward. The scale can change as more data arrives. If 3I Atlas disintegrates at perihelion, the rating drops to 0 or 1. Natural comet confirmed. If it alters trajectory significantly or transmits radio signals, the rating jumps to 7 or 8 or 10. The framework is flexible, responsive to evidence, designed to avoid premature conclusions while still quantifying the level of concern or interest an object warrants. Some scientists appreciate this approach. It provides structure for discussing ambiguous data, forces explicit reasoning about what constitutes evidence and how much weight different observations should carry. But others see the scale itself as a publicity stunt. Why do we need a Loeb scale? Because we need systematic ways to evaluate anomalies, Loeb responds. Because if we never quantify our uncertainty, if we never explicitly consider alternative explanations, we'll miss things. We'll default to comfortable interpretations and ignore data that doesn't fit. The academic backlash this time was equally fierce. Chris Lintott at Oxford called the alien probe suggestion absolute nonsense and an insult to the exciting work being done to understand 3I Atlas. NASA's Tom Statler was more diplomatic, but equally dismissive. It looks like a comet. It does comet things. Evidence overwhelmingly points to natural body. Other astronomers avoided commenting publicly, but made their skepticism clear in private conversations and on social media. The message was consistent. Stop crying wolf. Stop seeing aliens in every anomalous object. You're making the field look bad. Why such strong reactions? Several factors contribute. First, reputation protection. Astronomy constantly fights for funding and public trust. Maybe it's aliens, suggestions, even carefully framed ones, make the field look unserious to policymakers and the public. Makes it seem like astronomers can't distinguish science fiction from science. Every research proposal, every telescope funding request becomes harder to justify when the public thinks astronomers are chasing little green men. Second, methodological disagreement. Most scientists follow a conservative process. Gather data thoroughly, analyze carefully, publish conclusions only when certain. Loeb prefers a more public approach. Hypothesize openly, test through observation, revise based on evidence. Both methods are valid in principle. But the cultural clash is real. Loeb's approach feels like premature speculation to researchers who value caution. Their approach feels like timid groupthink to Loeb, who believes science advances through bold ideas that challenge consensus. Third, media distortion. Loeb might say in a paper, "We cannot rule out the possibility that this object could potentially show signatures consistent with artificial origin." The headline reads, "Harvard scientist says alien mothership approaching Earth." Then other astronomers spend weeks fielding questions from confused journalists and worried citizens. They deal with the consequences of sensationalism they didn't create, but get blamed for anyway because they're in the same field. Fourth, and perhaps most human, professional jealousy. Loeb has become a celebrity scientist. Appearances on Joe Rogan, interviews on major news networks, a best-selling book, Extraterrestrial, The First Sign of Intelligent Life Beyond Earth. Public recognition that most academics never achieve. Some colleagues resent this. They see someone getting famous for ideas they consider wrong or at least insufficiently proven. The celebrity scientist model bothers people who believe science should be about careful anonymous work, not personal brands and media appearances. But there's another interpretation of the backlash, darker and more uncomfortable. Maybe the strong reaction isn't fear that Loeb is wrong. Maybe it's fear that he's right. If 3i Atlas turns out to be artificial, if we're genuinely being visited by alien technology, that's a paradigm shift. Textbooks need rewriting. Theories need revision. Entire careers built on certain assumptions become obsolete overnight. That's threatening. Easier to dismiss the possibility than confront the implications. Easier to attack the messenger than engage with the message. This pattern isn't unique to astronomy. Every field resists paradigm shifts initially. Plate tectonics was ridiculed before it was accepted. Continental drift seemed absurd until the mechanism was understood. Germ theory faced fierce opposition from doctors who didn't want to believe they were spreading disease. Quantum mechanics looked like mathematical fantasy until experiments kept confirming its predictions. Revolutionary ideas always look crazy at first. The question is whether Loeb's hypothesis is revolutionary insight or wishful thinking. Time and data will tell. Meanwhile, Loeb founded the Galileo Project in 2021, after the Oumuamua controversy made clear that mainstream astronomy wouldn't systematically search for technological signatures. The project, funded by private donors, builds observatories designed to detect anomalous objects and phenomena. Multiple locations across the United States, Massachusetts, Pennsylvania, Nevada. Automated telescope systems, AI-powered analysis, real-time monitoring. The goal is to catch things as they happen, not months later when they're gone. To build systematic databases of observations that can be analyzed statistically, rather than relying on occasional anomalous detections. For 3i Atlas specifically, Galileo Project telescopes are watching. If the object releases probes during perihelion, if small spacecraft appear in Earth's vicinity in November or December, the project aims to detect them. Independent verification. Outside NASA's control, citizens can access the data, make their own determinations. That transparency is valuable regardless of what's found. If the search comes up empty, at least we looked. If it finds something, we're not dependent on government agencies deciding what to share. The project also studies UAPs, unidentified anomalous phenomena, what used to be called UFOs. Government reports from the Pentagon acknowledge that pilots and sensors detect things that can't be explained with current understanding. Objects that maneuver impossibly, that show no visible propulsion, that interfere with instruments. Maybe it's classified technology, maybe atmospheric phenomena we don't understand, maybe sensor errors, but maybe something else. The only way to know is rigorous scientific investigation. The Galileo Project provides that. Not conspiracy theories, not breathless speculation. Systematic data collection and analysis. Critics call this a waste of resources. Money better spent on established astronomy projects with proven scientific value. Loeb counters that the cost is minimal compared to other research programs, and if there's even a small chance of detecting evidence of extraterrestrial technology, the payoff justifies the investment. It's essentially insurance. Small premium against low probability, high impact discovery. Of course, the skeptical position has merit too. It's worth steel-manning the counter-arguments because they're not without logic. Interstellar objects should be common. Trillions exist in our galaxy, wandering between stars. We're only now developing technology sensitive enough to detect them. Seeing a few unusual ones early in our detection history doesn't mean they're artificial. It means our sample size is small and our understanding is incomplete. Natural processes are complex and often surprising. Many comets show unusual features that take years to explain. Doesn't mean they're artificial. Means our models are evolving. Every anomaly eventually gets a natural explanation once we understand the physics better. The WOW signal connection is statistically weak. 0.6% probability sounds low until you remember we're checking thousands of correlations. Some will match by chance. That's how statistics work. Sagittarius is a dense star field. Many objects come from that general direction. The trajectory alignment with the ecliptic is unusual but not unique. Over cosmic timescales, all trajectories occur eventually. We're seeing one rare example. Doesn't imply intent. The mass and lack of acceleration can be explained by a dense rocky core with an ice shell. Massive natural comets exist. They're rare, but not impossible. The forward-facing jet has been seen in other comets. Complex outgassing patterns depend on nucleus shape, rotation, composition. Models can accommodate it. The planetary encounter geometry, while improbable, is still within the realm of coincidence. The object's path is what it is. We notice patterns because humans are pattern-seeking creatures. Apophenia, the tendency to perceive meaningful connections between unrelated things, is a known cognitive bias. We're wired to see agency and intention even in random events. This served our ancestors well. Better to assume the rustling bush is a predator than ignore potential threats. But it leads to false positives. Seeing design where there's only chance. Occam's razor favors the natural explanation. The simplest hypothesis that fits the data is usually correct. Unusual comet is simpler than alien probe. Requires fewer assumptions. Doesn't invoke unknown technologies or unproven civilizations. Just extends what we already know exists. Comets, with properties at the edge of observed distributions, but not beyond physical possibility. From this perspective, Loeb is engaging in motivated reasoning, starting with the conclusion he wants and working backward to justify it. Both views are internally consistent. Both can point to evidence supporting their interpretation. The debate won't resolve until we have data that definitively rules out one explanation or the other. December's observations will help, but even then, ambiguity might persist. If 3i Atlas looks normal after perihelion, believers will say it's good camouflage. If it looks strange, skeptics will propose more exotic natural mechanisms. The human mind is infinitely creative at preserving cherished beliefs against contradictory evidence. What's clear is that this controversy transcends the specific object. It's about how science should operate, how conservative we should be in considering radical ideas. When extraordinary claims require extraordinary evidence, and when that standard becomes an excuse to ignore inconvenient data. Whether the search for extraterrestrial intelligence should focus only on radio signals, or whether we should also look for physical artifacts. Whether the vast silence we've encountered in decades of SETI means no one's out there, or means they're out there but staying quiet, listening rather than broadcasting, observing rather than announcing their presence. Loeb argues, we'll never find what we refuse to look for. If we categorically dismiss every anomalous object as natural before investigating thoroughly, we guarantee negative results. Self-fulfilling prophecy. The greatest discovery in human history, confirmation we're not alone in the universe, could be staring us in the face and we'd miss it because we didn't want to look foolish by taking the possibility seriously. His critics argue that crying wolf too often means no one listens when the real wolf arrives. That science depends on credibility, and wild speculation undermines that credibility. That the public already confuses science with science fiction, and researchers have a responsibility not to blur those lines further. The debate continues. The object approaches perihelion, and in December, we'll have more data. Not enough to settle everything. Never enough for that, but enough to move the conversation forward, to adjust our probabilities, to decide whether 3I Atlas deserves continued scrutiny or can be filed away as an interesting but natural visitor from the space between stars. From the moment 3I Atlas was confirmed as an interstellar visitor, NASA's messaging has been remarkably consistent. It's a comet, a natural object from beyond our solar system. No threat to Earth. All observations align with cometary behavior. Tom Statler, NASA's lead scientist for solar system small bodies, has repeated these assurances in every interview, every press statement, every public comment. It looks like a comet. It behaves like a comet. The evidence overwhelmingly points to this being a natural body. Simple, clear, reassuring. The kind of statement designed to calm public concern and redirect attention away from more exotic possibilities. The framing matters enormously. When media outlets report on 3I Atlas, they echo NASA's language. Interstellar comet visits solar system. Not anomalous object raises questions. Not scientists debate nature of mysterious visitor. Just comet. Natural. Understood. Move along. This framing could be entirely appropriate if the object truly is benign and ordinary. No reason to alarm the public unnecessarily over something that poses no danger and requires no special concern. But the framing could also be strategic. A conscious choice to project confidence even when internal uncertainty exists. To present conclusions before analysis is complete. To shape public perception before independent researchers can complicate the narrative. This is where institutional behavior becomes fascinating, not necessarily in a sinister way, but in a revealing one. NASA exists in a complex environment. It's a scientific agency, yes, dedicated to discovery and exploration, but it's also a government bureaucracy, answerable to Congress, subject to political pressures, dependent on public support for funding. The agency must balance competing priorities: truth-seeking and reputation management, scientific integrity and public confidence, transparency and careful disclosure. When these interests align, no problem. When they conflict, choices get made about which priority takes precedence. Let's trace the timeline of what NASA told the public and when. July 1st, 2025. Object discovered. Announcement comes within days. Initial reports cautiously note possible interstellar origin. July 7th. Interstellar trajectory confirmed through follow-up observations. Designation 3I Atlas made official. Minor Planet Center updates its databases. News coverage increases. July through August. Regular updates. Hubble images released showing the teardrop-shaped coma and forward-facing jet. James Webb Space Telescope observations announced. Size estimates provided, though with enormous uncertainty ranges. Water vapor detection confirmed through spectroscopy. All of this is good science communication, timely and transparent. August. The comet classification strengthens. A faint tail begins to form. Media coverage peaks. Scientists express excitement about this rare opportunity to study interstellar material up close. Everything seems normal, or as normal as studying a visitor from another star system can be. September. Preparations intensify for the Mars flyby. Multiple spacecraft position themselves for observation. Public interest reaches fever pitch in astronomy communities. NASA's website updates regularly with trajectory information and observation schedules. Everyone knows October 3rd will be the critical date, the best chance for detailed imaging. Then October 1st, government shutdown. The website stops updating. The last message posted. Due to the lapse in federal government funding, this website is not being updated. Social media accounts go silent. No press releases, No briefings. The normally steady flow of information from NASA dries up completely. October 3rd, Mars flyby occurs. No live updates. No preliminary reports. Radio silence from the agency that had been so communicative just days earlier. October 4th, select media outlets receive briefings from NASA officials. No images provided. No technical data released. Just verbal assurances that 3I Atlas appears to be a regular comet. Nothing unusual detected. Everything consistent with a natural body. Based on what analysis exactly? Unclear. The Mars Reconnaissance Orbiter data supposedly requires days of processing. Engineers need to check transmissions. Scientists need to calibrate instruments. Yet conclusions are drawn within 24 hours during a shutdown when most personnel are furloughed. October 5th through 12th. Information vacuum. No official Mars orbiter images released, despite growing public demand. ESA, the European Space Agency, also remains silent on their observations from Mars Express and Trace Gas Orbiter. Amateur astrophotographers share enhanced versions of Perseverance rover images, but these are ambiguous at best. Social media speculation intensifies. NASA's media team, furloughed, unable to respond to inquiries. The agency that was so forthcoming in July and August has gone dark at precisely the moment when everyone wants information most. This timeline reveals a pattern. Early transparency during the discovery phase when the object was distant and the observations were preliminary. Sudden opacity during the critical observation window when the best data should be arriving. Selective briefings after the flyby providing conclusions without supporting evidence. Either this represents bureaucratic dysfunction, the government shutdown, causing unavoidable delays as NASA claims, or it represents strategic information management, controlling what the public learns and when they learn it. There's historical precedent for NASA's communication patterns raising questions. Apollo 11 in 1969, 2 minutes of radio silence during the lunar approach that was never fully explained. Official story, switching antennas. Maybe true, maybe conveniently ambiguous. The face on Mars from the Viking orbiter in 1976. NASA releases an image showing what looks like a carved face. Public fascination explodes. Later missions reveal it's just a hill with interesting shadows. Natural formation. But the initial handling, releasing the image without immediate context, fed decades of conspiracy theories about ancient Martian civilizations. Space Shuttle Mission, STS-48, in 1991. Video shows objects changing direction in space. UFO researchers claim alien spacecraft. NASA eventually explains. Ice particles reacting to thruster fire. Probably correct, but the explanation came slowly, after speculation had already entrenched. Phoenix Mars lander in 2008. Images suggest possible water droplets on the spacecraft's strut. Liquid water on Mars would be revolutionary. NASA downplays the observation, focuses on confirming water ice in the soil. Later analysis suggests the droplets probably weren't liquid after all. But the initial caution looked like suppression to observers who wanted the discovery to be real. In each case, the pattern is similar. Ambiguous observation. Public speculation fills the vacuum. NASA's eventual explanation is reasonable but delayed. The delay creates fertile ground for alternative theories. By the time official explanation arrives, competing narratives have already taken root. Why not explain immediately? Several possibilities, none mutually exclusive. First, scientists genuinely need time to analyze properly. You don't want to speculate publicly before peer review, before multiple experts examine the data. before you're confident in your conclusions. Premature announcements that later get revised damage credibility more than delayed announcements that get it right the first time. This is responsible caution, standard scientific practice. Second, legal and procedural requirements. Multiple agencies must coordinate. NASA, ESA, universities, international partners. Data sharing agreements specify review processes. Releases require approval from various administrative levels. This takes time regardless of content. It's bureaucracy, not conspiracy. Just the reality of large organizations operating across national boundaries with complex stakeholder relationships. Third, strategic communication. Test public reaction with limited information. See how people respond. Adjust your message based on feedback. Gradual disclosure reduces panic, allows people to process information in digestible chunks rather than overwhelming them with everything at once. From a public relations standpoint, this makes sense. From a transparency standpoint, it looks like manipulation. Fourth, and this is the conspiracy interpretation, actual cover-up. They know more than they're saying. They're releasing only what fits the preferred narrative, while suppressing anomalous findings that would raise uncomfortable questions. They've seen something in those Mars images that doesn't match the "just a comet" story, and they're deciding how to handle it without causing public alarm or admitting their initial assessment was wrong. Most likely, the truth involves combinations of the first three explanations. Option 4 requires more evidence than we currently have. But history shows institutions do conceal information when they believe disclosure would cause more harm than good. Not always wrongly, either. National security sometimes legitimately requires secrets. Public safety can justify delayed warnings until proper context is prepared. Preventing panic is a valid consideration when information could trigger irrational mass responses. The question is whether 3i Atlas falls into that category of information requiring managed disclosure. And that question leads us back to a document that keeps appearing in discussions of how NASA might handle discovery of extraterrestrial intelligence. The Brookings Report from 1960 deserves deeper examination because it explicitly addresses exactly this scenario. NASA commissioned the study from the Brookings Institution, a respected think tank, asking them to consider implications of space exploration for human affairs. One section dealt with potential discovery of extraterrestrial life or artifacts. The key passage, often quoted in conspiracy circles, but worth reading carefully, states, "Anthropological files contain many examples of societies sure of their place in the universe which have disintegrated when they have had to associate with previously unfamiliar societies." The report goes on to suggest that discovery of superior alien intelligence could be particularly destabilizing. It notes that scientists and engineers might be most affected, having their fields of expertise suddenly obsolete or trivial compared to alien knowledge. It recommends careful study of how to present such a discovery. Who should be told first? How to prepare the public mindset. The report doesn't mandate secrecy, doesn't say hide the truth, but it does recommend caution, preparation, strategic timing. Now fast forward 65 years. Has society changed enough that these concerns are outdated? Would announcement of alien artifact cause social collapse? Probably not total civilization-ending collapse. Modern society is more resilient, more scientifically literate, more culturally diverse in its expectations. But markets could panic. Stock values in certain sectors could crash overnight while others boom. Religious institutions would face crisis. Some theologies specifically exclude alien life, others could adapt easily, incorporating the discovery into existing frameworks. But the specifics matter. Are these aliens morally equivalent to humans? Do they have souls? Do they need salvation? These questions would become urgent, not just theological exercises, but practical concerns affecting billions of believers. Governments would scramble for coordinated response. You can't have competing national strategies for species-level contact. International cooperation would suddenly become critical in ways it hasn't been before. The United Nations would take on new importance, or new institutions would form specifically to handle extraterrestrial relations. Space defense, contact protocols, resource allocation, all would need global frameworks. Economies would fluctuate wildly. Some sectors would crash. Traditional energy if aliens offer advanced power systems. Defense industries. If technology gaps make human weapons obsolete. Pharmaceutical companies if alien medicine exists. Other sectors would boom. Communications, transportation, materials, science. Anything potentially enhanced by alien knowledge or trade. Long-term effects are unpredictable. Depends entirely on the nature of contact. Friendly exchange of information? Potentially transformative in positive ways. Hostile encounter? Everything changes. Neutral observation from a distance? Uncertainty persists, possibly more unsettling than either extreme. Individuals would respond across a spectrum. Some with fear, existential dread, sense that humanity is now vulnerable to unknown dangers. Some with excitement, feeling we're part of something larger, that the ultimate discovery has been made. Some with denial, insisting it must be hoax or misinterpretation, unable to accept such a fundamental revision of reality. Most with confusion, wondering what this means for daily life, for their jobs, their families, their plans and hopes and dreams. So from a government perspective, maybe gradual disclosure makes sense. Don't hit people with aliens confirmed headlines. Instead, ease them in. First, we found an interstellar object. Okay, people can handle that. Extrasolar material visits sometimes. Then, it has unusual properties. Interesting. Scientists are studying it. Then, some researchers think it might be artificial. Controversial claim. Most experts skeptical. Finally, after months of preparation, after thorough analysis, we now believe this object shows technological signatures. Each step allows adjustment. By the time you reach the conclusion, people are primed. They've had time to consider possibilities. The shock is reduced. This could be happening with 3i Atlas right now. We've had months to get comfortable with an interstellar visitor, with the idea that such objects exist and sometimes pass through, with the notion that this particular one is large and interesting, with awareness that it has puzzling features. If NASA's assessment eventually changes from definitely natural to possibly artificial, the public is already somewhat prepared, can absorb that update better than if it came as sudden revelation with no prior context. This is the most charitable interpretation of NASA's communication approach. The less charitable view, they're stalling because they don't know what they're seeing and don't want to admit uncertainty. The most cynical interpretation, they know exactly what they're seeing and they're hiding it. Reality is probably mundane. Bureaucracy, caution, standard procedures that, from the outside, look like evasion, but from the inside, feel like responsible science. The European Space Agency's role complicates the picture. ESA operates independently, different funding sources, different political structures. Yet they're also silent on detailed Mars imagery. Why? Coordination with NASA makes sense for joint observations. Data sharing agreements require synchronized release so one agency doesn't scoop the other. but complete silence from both organizations, especially during a U.S. government shutdown that shouldn't affect European operations, feels coordinated in ways that feed suspicions. If ESA released first, it would demonstrate NASA isn't solely controlling information, would show international scientific community operates independently. Instead, coordinated silence from both agencies, suggesting unified messaging strategy. This maintains consistency, but looks suspicious. Makes it seem like narrative is being crafted rather than data being shared. Whether that perception is fair or not, it erodes trust. What are they not telling us? Assuming best intentions, assuming NASA genuinely believes 3I Atlas is natural, what information might still be withheld? Full uncertainty ranges for one. Public gets probably this size, but internal documents might show error bars so large that this size is barely constrained at all. Could be much larger, much denser, much stranger than public estimates suggest. Competing hypotheses under internal debate. Some researchers might favor exotic interpretations while others push conventional ones. Those debates don't make it to press releases. Only the consensus view, or the view leadership wants projected, reaches the public. Classified observations remain hidden by definition. Military satellites see everything NASA sees and more, with better resolution. But that data stays classified for national security reasons. We'll never see it unless it gets leaked. Contingency planning also stays private. What if trajectory changes? What if something deploys? Plans exist for various scenarios, but sharing those plans publicly might cause unnecessary alarm. International data and disagreements from other nations' space agencies might contradict U.S. assessments. Those disagreements won't be publicized if they complicate the unified message. And the close-up imagery from Mars orbiters, the high-rise photos that should show 3I Atlas in unprecedented detail, remain unreleased as of this writing. Processing complete or not? Unknown. If complete, why not released? If incomplete, why the premature conclusions about the object's nature? These questions don't have public answers yet. Maybe they will eventually. Maybe the images will emerge and show exactly what NASA said, a comet, normal and unremarkable. Or maybe they'll show something else, something that takes longer to explain, longer to contextualize, longer to prepare the public to understand. NASA has earned skepticism through past communication missteps, through the appearance of gatekeeping, of deciding what the public needs to know rather than sharing information openly. But the agency also faces an impossible task. Maintain scientific rigor while satisfying public curiosity. Deliver information in real time during government shutdowns and funding crises. Make no mistakes that could damage credibility or cause panic. Explain complex phenomena to audiences with varying levels of scientific literacy. Do all this while under constant scrutiny from people ready to interpret any hesitation as evidence of conspiracy. No wonder they're cautious. No wonder they stick to simple messages even when reality is complicated. The question is whether that caution serves the public interest or obscures truth that citizens have the right to know. And whether, when December comes and 3I Atlas emerges from behind the sun, the data will finally settle the debate or just deepen the mystery further. October 19th, 2017. The Pan-STARRS telescope in Hawaii, designed to scan the sky for potentially hazardous asteroids, detected something moving unusually fast against the background stars. At first, astronomers thought it might be a comet or asteroid from our own solar system. But as observations accumulated over the following days, the truth became undeniable. The trajectory was hyperbolic. The object wasn't orbiting our sun. It was just passing through, moving too fast for solar gravity to capture it. This was the first confirmed interstellar visitor in human history. The first macroscopic object from beyond our solar system that we'd ever detected. They named it Oumuamua, a Hawaiian word meaning scout or first messenger. Appropriate, given what followed. The name carried weight. Scout implies purpose, reconnaissance, an advance party sent ahead of something larger. Whether the namers intended that implication or simply meant first of its kind, the word resonated with people who wondered what this visitor might mean. But Oumuamua was already leaving when we found it. Moving at 87 kilometers per second relative to the sun, it was outbound, heading back into interstellar space. We had only weeks to study it before it faded beyond the reach of our telescopes. Every observation was precious, rushed, captured before the opportunity vanished forever. And what those observations showed baffled scientists in ways that still haven't been fully resolved. The shape was highly elongated, length roughly 10 times the width. Imagine a cigar or a pancake, depending on viewing angle. The precise geometry remained uncertain because we never got close enough to resolve the surface directly. We inferred the shape from how brightness varied as the object tumbled. It completed one rotation about every 8 hours, and during that rotation, brightness changed dramatically. This indicated something far from spherical. The ratio of long axis to short axis, around 10-1. Nothing quite like it had been seen before in solar system comets or asteroids. Extreme elongation suggests either a fragment broken from something larger or a structure designed to be that shape for a reason. The color was reddish, suggesting long exposure to cosmic rays. Organic materials in space turn reddish over time as radiation breaks down complex molecules. This indicated the object was ancient, billions of years old, consistent with having wandered through interstellar space for epochs before encountering our solar system. Old ice, old rock, carrying history from a distant star system that we'd never identify. Then came the acceleration. As Oumuamua moved away from the sun, it sped up. Not much, but measurably. More than gravity alone could explain. For a comet, this makes perfect sense. As the sun heats the icy surface, frozen volatiles sublimate, turning directly from solid to gas. This gas jets out, and by Newton's third law, the reaction pushes the comet. It's called the rocket effect. We see it in every active comet we study, except Oumuamua showed no tail, no coma, no visible signs of outgassing. The Spitzer Space Telescope was brought to bear, one of our most sensitive infrared instruments. It looked for carbon-based molecules, for organic compounds, for dust, for any evidence of material streaming off the object. Found nothing. Deep observations revealed no cometary activity, despite the acceleration that required some force beyond gravity. This was the central mystery. The object was accelerating like a comet, but showed no signs of being a comet. Enter Avi Loeb and Shmuel Bialy with their light sail hypothesis. A sufficiently thin sheet of reflective material, perhaps artificially constructed, would experience acceleration from solar radiation pressure alone. No outgassing required. The sunlight pushes directly on the surface. The math worked. The acceleration matched what would be expected from a sail maybe a millimeter thick or less. The elongated shape made sense if you were viewing the sail edge on. The tumbling motion could result from imbalanced forces on a thin sheet. Everything fit. The paper was published in a peer-reviewed journal. The calculations were rigorous. The hypothesis was presented as possibility, not certainty. One explanation among several that deserved investigation. But the reaction was visceral. Absolute nonsense, critics said. Publicity-seeking behavior. Irresponsible to even suggest alien technology without extraordinary evidence. Meanwhile, alternative natural explanations proliferated. Hydrogen icebergs, frozen molecular hydrogen that would sublimate invisibly. Nitrogen ice chunks like Pluto's surface. Fractal dust clouds held together loosely. Each explanation had problems of its own, required special conditions we'd never observed, but each was preferable to saying the word alien in serious scientific discourse. The debate never concluded. Oumuamua left. It's beyond our reach now, beyond Pluto's orbit, heading out into the interstellar medium. We'll never see it again, never get another chance to study it up close. The mystery remains open, interpretations still contested, no consensus reached. Some papers conclude it was probably a comet with unusual composition. Others note that every natural explanation proposed has significant flaws. The uncertainty persists. Then came 2019 and 2I Borisov, discovered by Crimean amateur astronomer Gennady Borisov. This second interstellar visitor was different from Oumuamua in almost every way. It looked like a normal comet. It had a bright nucleus surrounded by fuzzy coma. It developed a clear tail as it approached the sun. Spectroscopy revealed familiar cometary materials: water ice, carbon dioxide, organic molecules. It behaved exactly as comet physics predicted. Its trajectory was hyperbolic, confirming interstellar origin, but otherwise there was nothing mysterious about it. Just a comet from another star system, acting like comets we'd seen thousands of times before. 2I Borisov calmed some of the hysteria around Oumuamua. See, people said, interstellar objects can be normal. Not everything from beyond needs exotic explanation. Sometimes a comet is just a comet, even if it came from another star. The observations of 2I Borisov provided the first detailed composition data for interstellar material, showing that planetary formation processes might be universal. Comets form similarly around different stars. The chemistry is comparable. We're not seeing wildly alien materials, just familiar substances that formed in different solar systems billions of years ago. Now arrives 3I Atlas in 2025, and it combines features of both predecessors while adding new mysteries. The size difference is the first striking contrast. Oumuamua was maybe 400 meters long, small. 2I Borisov was less than a kilometer across, normal comet size. 3I Atlas is enormous, between 5 and 20 kilometers in diameter, depending on estimates. That's 50 to 100 times larger than Oumuamua. Orders of magnitude more massive. The shape appears different too, though we're still waiting for definitive high-resolution imaging. Oumuamua was extremely elongated. 3I Atlas seems more conventional in shape, possibly spheroidal or ellipsoidal, but not the extreme cigar geometry of the first visitor. This makes it look more natural, more like what we'd expect from a comet nucleus. Unless the shape itself is part of camouflage, a design choice to appear natural while concealing something else inside. Activity levels differ dramatically. Oumuamua showed no tail, no visible outgassing despite acceleration. 2I Borisov was highly active, bright coma and long tail throughout observation. 3I Atlas falls somewhere between. It showed that strange forward-facing jet initially, minimal tail at first, then developed more normal cometary appearance later. The sequence was odd, not matching typical comet evolution, but it did eventually show activity consistent with ice sublimating as it heated. The acceleration issue flips. Oumuamua accelerated mysteriously without visible gas. 3I Atlas shows massive outgassing without measurable acceleration. Opposite problems. One object pushed by invisible forces. the other resisting visible forces through sheer mass. Both unusual in different directions. This suggests either we fundamentally misunderstand comet physics, our models are more incomplete than we thought, or we're looking at objects that don't follow natural comet behavior because they're not natural comets. Color and composition show differences. Oumuamua was reddish, suggesting ancient cosmic ray exposure. 3I Atlas shows more typical comet colors. Spectroscopy reveals water vapor, hydroxyl radicals, probably carbon dioxide. Familiar materials. Nothing exotic. The chemistry looks normal, which either means it's a normal comet or means the exterior is designed to look normal, while concealing internal structures we haven't detected. Discovery timing matters. Oumuamua was spotted late, already leaving the inner solar system. We got one shot at observation, then it was gone. 2I Borisov was found with more warning, allowing months of study as it approached and then departed. 3I Atlas was detected earliest of all, months before perihelion, giving unprecedented opportunity for observation campaigns. Multiple spacecraft positioned to observe, ground telescopes scheduled time, amateur astronomers prepared. This should be the best studied interstellar object yet, if we can get the data, if agencies release what they're seeing, if the government shutdown doesn't obscure the critical observations. The trajectory differences reveal interesting patterns. Oumuamua came from the direction of Vega, moving fast, on a path that didn't align particularly with the ecliptic. 2I Borisov arrived from a different direction, also on an inclined trajectory. Random, as you'd expect from objects ejected randomly from distant star systems. 3I Atlas came from Sagittarius, aligned closely with the ecliptic, retrograde motion, passing near multiple planets. This trajectory stands out. Either it's a rare coincidence, or it was chosen, navigated, designed to enable specific mission objectives. What can we learn from comparing all three visitors? If they're all natural, the diversity is interesting. Shows that interstellar objects come in variety, just like solar system objects do. Some comets, some asteroids, some weird in-between things. Some active, some inert. Size distribution, from small to large. Compositions varying based on where and when they formed. Nothing sinister, just natural variation in a galaxy full of planetary systems, ejecting material into interstellar space. But if any of them are artificial, the diversity might mean something else. Different designs for different purposes. Oumuamua as a fast scout, lightweight and maneuverable, using solar pressure for propulsion, possibly deploying smaller probes we never detected. 2I Borisov as a natural comet used for comparison to see how we react to clearly natural visitors versus ambiguous ones. 3I Atlas as a larger mission, mothership carrying equipment or probes, approaching slowly enough for detailed observation of the inner solar system over extended time. This is speculation built on speculation, but it illustrates how the same data supports multiple interpretations depending on your priors. If you start assuming everything in space is natural, the three visitors are just random interstellar debris with varying properties. If you start open to the possibility of artificial objects, patterns emerge that suggest intentionality. The question is which prior is more reasonable, which interpretation better fits all the evidence, and whether we're sophisticated enough to distinguish design patterns from random noise. One lesson Oumuamua taught us: interstellar objects visit more often than we thought. Before 2017, we had theories suggesting maybe one detected per decade once our telescopes got sensitive enough. Instead, we've confirmed 3 in 8 years. As detection technology improves, As the Vera Rubin Observatory comes online with its ability to scan the entire visible sky every few nights, we expect to find interstellar visitors monthly, possibly weekly. By decade's end, we might have dozens cataloged, possibly hundreds. This upcoming flood of data will help. If most interstellar objects are clearly natural, straightforward comets and asteroids, with Oumuamua and 3I Atlas as weird outliers, that's one thing. Outliers happen. Statistical distributions have tails. 2 strange objects among 50 normal ones is less concerning than 2 strange objects when we've only seen 3 total. Sample size matters. The pattern only becomes clear with more data points. But what if most interstellar visitors show anomalies? What if strange trajectories, unusual compositions, unexpected accelerations are normal rather than exceptional? That would suggest something fundamental about our understanding is wrong. Either interstellar space is much more active and dynamic than we model, with processes we don't understand creating objects with properties we can't explain, or the galaxy is more crowded with artificial objects than we've assumed. Probes from various civilizations, traveling between stars, some ancient and inert, others active and observing. If every interstellar object we detect over the next decade shows puzzling features, that's when the conversation changes. That's when even conservative scientists have to seriously consider alternative explanations. We're at the beginning of interstellar object astronomy. 3 confirmed detections. Maybe a dozen candidates awaiting confirmation. A field in its infancy. The patterns we think we see might be mirages, artifacts of small sample size, and confirmation bias. Or they might be real signals, genuine evidence of something important that requires urgent investigation. Oumuamua posed the question, could this be artificial? 2I Borisov seemed to answer, no, natural objects can explain interstellar visitors. 3I Atlas reopens the question with new force. Because if 2 out of 3 confirmed visitors show significant anomalies, that's not a tale of the distribution anymore. That's potentially a bimodal distribution, 2 populations, natural interstellar debris and something else. Something that looks similar, but isn't quite the same. Something we need better tools and better theories to distinguish. The comparison between these 3 visitors matters because it's the only comparison we can make. They're the only data points we have. And depending on how you interpret those points, you get very different pictures of what's happening. Natural comets wandering through, exactly as astrophysics predicts. Or the first confirmed examples of extraterrestrial technology, arriving with increasing frequency, studying us with increasing attention, preparing for something we can't yet anticipate. December will add more data to this comparison. Will 3I Atlas after perihelion look more like Oumuamua, strange and accelerating, more like 2I Borisov, normal and cometary, or something entirely new? A third pattern suggesting a third possibility we haven't considered. The wait is measured in weeks now. The answer approaches whether we're ready for it or not. The Fermi paradox haunts every astronomer who looks at the night sky with understanding. Named for physicist Enrico Fermi, who asked the deceptively simple question during a lunch conversation in 1950, where is everybody? The universe is ancient, 13.8 billion years old. Our galaxy alone contains hundreds of billions of stars, many with planetary systems. Even if life is rare, even if intelligence is rarer still, the sheer numbers suggest thousands or millions of civilizations should exist across the galaxy. Some younger than us, still developing, some older, perhaps by millions or billions of years. With that much time, even traveling at slow speeds, a civilization could colonize the entire galaxy multiple times over. So where are they? Why don't we see evidence everywhere? Why no megastructures visible in telescope surveys? No obviously artificial radio signals in decades of SETI listening? No alien artifacts found in our solar system? The silence is profound and troubling. Various explanations have been proposed. Maybe life is incredibly rare, Earth is unique, we're alone. Maybe intelligence is the rare step. Many planets have bacteria, but few develop complex cognition. Maybe there's a great filter, some obstacle that destroys civilizations before they can spread, and we either haven't reached it yet, or we're extraordinarily lucky to have passed it. Maybe advanced civilizations transcend physical reality, uploading into digital existence or ascending to higher dimensions, leaving the material universe behind. Or maybe they're all hiding, all staying quiet, all refusing to broadcast their presence because doing so would be suicidal. This is the dark forest hypothesis. The theory gets its name from Liu Cixin's science fiction novel, but the logic predates the book. It's based on game theory and evolutionary psychology. Imagine a dark forest at night. You're armed, alert, moving carefully through the trees. You know other hunters are out here too, also armed, also alert. If you make noise, you reveal your position. Other hunters might see you as threat. They might shoot first before you can shoot them. Even if you're not hostile, they don't know that. They can't know that. In the darkness, with imperfect information, the safest strategy is to eliminate potential threats before they can become actual threats. Apply this to the galaxy. Civilizations might be common, but no one transmits. No one advertises. Everyone listens, observes, stays hidden. Because any sufficiently advanced civilization could be an existential threat to any less advanced one. And you can never be certain of intentions. Even if another civilization seems peaceful, even if they broadcast friendship, how do you know it's genuine? How do you know their technology won't make your civilization obsolete or enslaved? How do you know they won't decide you're a future threat and eliminate you preemptively? The mathematics of this situation are grim. If civilizations are distributed across the galaxy, if communication lag between stars is years or decades, if you can't negotiate in real time or establish trust quickly, then first contact becomes a lethal decision point. Do you reveal yourself? Do you trust the other civilization? Or do you strike first, ensuring your survival by eliminating potential competition before they can threaten you? From a pure survival standpoint, paranoid aggression makes terrible sense. It's evolutionary stable. Peaceful civilizations that broadcast get destroyed. Aggressive civilizations that stay hidden and strike preemptively survive. Over time, the galaxy fills with silent predators, each watching, waiting, ready to eliminate any detected civilization before it becomes dangerous. This is a dark explanation for the silence. Not that life is rare, not that intelligence doesn't arise, but that everyone who achieves spaceflight learns the same lesson. Shut up, listen, hide. And if you detect another civilization, you face a choice. Ignore them and hope they don't notice you, or eliminate them before they can threaten you. There's no safe middle ground, no guaranteed way to establish trust at interstellar distances, with communication lag measured in years. Now consider humanity's situation in this framework. We've been broadcasting for over a century. Radio, television, radar signals leaking into space. The sphere of our electromagnetic presence expands at light speed, currently about 120 light-years in radius. Any civilization within that sphere could have detected us, could know we're here, could be responding. Travel between stars takes time even at high fractions of light speed. If they launched a probe or ship when they first detected our signals, it could be arriving now. Right now, this decade, these years, the timing aligns. Our earliest powerful transmissions were in the 1920s and 30s. Radio broadcasting, radar development. World War II saw enormous increases in radio traffic. The signal sphere from that era has reached stars within 100 years of Earth. If anyone was listening, they heard. If they sent something back, moving at 10% of light speed, it would take 1,000 years to cross 100 light years. Too long. But if they sent something faster, or if they had probes already in the galactic neighborhood, moving between interesting star systems, response time drops dramatically. A probe stationed a few light years away, moving at half light speed, could reach us in a decade or two after detecting our signals. Interstellar objects start looking different in this context. Oumuamua arrives in 2017, just as our technology becomes sophisticated enough to detect small objects passing through the inner solar system. 3I Atlas arrives in 2025, both after our signals spread. Both from regions of space we've been broadcasting toward for decades. Coincidence? Statistically, maybe. But dark forest logic suggests these could be reconnaissance, assessment missions, probes sent to evaluate the civilization that revealed itself, to determine threat level, to decide what response is warranted. The probe would need to be subtle. Can't announce itself, obviously. Can't transmit in ways we'd recognize. Needs to observe without being detected as artificial. Best strategy: look natural. Masquerade as comet or asteroid. Use minimal propulsion, only when necessary, preferably hidden behind the sun or during moments we can't observe. Gather intelligence about our technology, our level of advancement, our potential as future threat or resource. Then report back or take action based on mission parameters. What would such a probe look for? Several indicators of threat level. Technology development rate. How fast are we advancing? Are we still using chemical rockets, or do we have more sophisticated propulsion? Do we have nuclear weapons? How widespread? What's our space presence? Are we confined to one planet or spreading? What's our social organization? Unified world government or fractured nations? Are we peaceful or aggressive? History of warfare or cooperation? All this data feeds into assessment models, algorithms, decision trees about what we represent as potential future civilization. The WOW signal fits this framework uncomfortably well. August 15th, 1977. Ohio State's Big Ear Telescope detects a powerful narrowband transmission at the hydrogen line frequency. 72 seconds. Never repeated. Origin: Sagittarius. The same direction 3I Atlas is approaching from. Loeb's calculation shows 3I Atlas was approximately 600 astronomical units away in 1977, within 9 degrees of the WOW signal's origin. Probability of this alignment: 0.6%. If the signal came from 3I Atlas, the scenario becomes clear. An object moving through interstellar space, already on course toward our solar system, or able to adjust course, sends a brief transmission. A test. Are you listening? Can you detect? Do you have the technology to notice artificial signals? We detected it. Jerry Amons circled the printout, wrote "WOW" in the margin, and humanity began discussing what it might mean. The object, if it was watching, now knows. We're listening. We heard. We're technologically capable of detecting radio transmissions at interstellar distances. Response: the object continues inward. Takes 48 years traveling at sublight speeds. Approaches slowly, carefully, looking natural. Arrives in 2025 when our technology is more advanced, our space presence more developed, our potential as threat or resource better defined, studies us during the approach, positions itself to observe multiple planets, plans deployment of smaller probes during perihelion when we can't watch, and waits to see how we react, what we do, what we're capable of. This is speculation built on correlation, pattern seeking in limited data. But it's internally consistent. It explains the timing, the trajectory, the anomalies in ways that natural comet explanations struggle with. It provides motivation where physics alone provides none. It suggests intent where others see only chance. If dark forest theory is correct, if 3I Atlas is reconnaissance, what happens next matters enormously. How we respond, what we do, what signals we send through our behavior, all of this gets evaluated. Calm scientific observation suggests a mature civilization, rational, not immediately threatening. Panic and military mobilization suggest we're primitive, fear-driven, potentially dangerous as we advance. Ignoring the object completely might indicate we're not advanced enough to recognize significance, not yet a concern, can be monitored passively for a few more centuries before reassessment. Currently, we're showing divided response. Some scientists take 3I Atlas seriously. Most dismiss it as natural. Public attention is high but scattered. Social media debates rage. No unified governmental reaction. International space agencies watch independently, coordinating to some degree but not presenting unified human response. From an outside observer's perspective, this indicates we're technologically capable but politically fragmented. Can detect anomalies but can't agree on interpretation. Have space presence but not coordinated space policy. Interesting but not yet threatening. Maybe worth watching, not yet worth eliminating or contacting directly. The December perihelion becomes critical in this framework. If probes deploy, if 3I Atlas uses the hidden passage behind the Sun to release observation equipment into orbits around Earth or other planets, we might not detect them immediately. These probes would be small, dark, designed for stealth. They'd position themselves to observe continuously, monitor our communications, track our space launches, assess our technological progress, report findings back to wherever 3I Atlas originated, light years away, decades or centuries of communication lag. Or the assessment might conclude, we're a threat that needs addressing before we spread. The probes could be weapons, or reconnaissance before weapons arrive. Determining optimal strike points, assessing our defenses, preparing for elimination event that looks natural, untraceable. Asteroid redirected from outer solar system, appears to be random impact. Catastrophic extinction event, no evidence of artificial cause. Another civilization gone before it could threaten anyone. This is worst-case dark forest scenario, and it's worth stating clearly, this is probably not happening. The likelihood that 3I Atlas is an alien weapon is vanishingly small. Natural comet remains by far the most probable explanation. But the logic of dark forest theory is sound even if its application here is not. If you accept that civilizations should be common, if you accept that we're broadcasting our presence, if you accept that some civilizations might be aggressive, then you have to accept that first contact might not be friendly. Might not be Star Trek, peaceful exploration. Might be elimination before we become competition. Humanity has no protocols for this scenario. We have SETI post-detection protocols for radio signals, steps to verify, inform international authorities, coordinate response. But for physical visitors? For objects that might be probes or weapons? No agreed procedures. No unified command structure. No way to guarantee coordinated human response rather than competing national reactions that look primitive and chaotic. This needs to change, regardless of whether 3I Atlas is natural or artificial. Because even if this object is a comet, the next one might not be. We're entering an era where interstellar visitors arrive regularly. We're detecting them monthly within the decade. Among those visitors, if even a small fraction are artificial, we need frameworks for assessment, investigation, and response. We need international protocols that activate when certain anomaly thresholds are met. We need procedures for escalating from scientific curiosity to security concern when indicators suggest artificial origin. We need to decide, as a species, how we want to present ourselves to potential observers. Do we want to appear unified or divided? Peaceful or militaristic? Advanced or primitive? Open or secretive? These choices affect how we're perceived and judged. They might affect whether we're contacted peacefully, monitored neutrally, or targeted preemptively. December will provide more data. If 3I Atlas emerges from perihelion on predicted trajectory, looking normal, all of this is moot. Natural comet confirmed. Dark forest remains theoretical. We continue broadcasting happily, hoping for contact, not worried about threats. If trajectory changes, if objects deploy, if radio signals transmit, the conversation shifts dramatically. Suddenly we're dealing with confirmed artificial visitor. Suddenly the questions become urgent, practical, immediate. What does it want? Who sent it? What should we do? The scenarios range from benign to catastrophic. Best case, passive observation. They're studying us from a distance, gathering data, no interference planned. We might never even detect the observation. Life continues. We advance technologically. Eventually, we develop interstellar capability ourselves and join whatever galactic community exists, if any. Middle case, active investigation. They don't stay distant. Probes enter our atmosphere, study Earth directly. We see them as UAPs, unidentified anomalous phenomena. Government acknowledges unknowns. Public demands answers. First contact becomes slow reveal over years or decades as evidence accumulates beyond denial. Worst case, existential threat. They've determined we're dangerous, will become dangerous, need elimination. Options include asteroid impact, biological weapon, electromagnetic pulse knocking out technology, or simply waiting and watching while we destroy ourselves with climate change or nuclear war. No action needed. The uncertainty might be most unsettling. Not knowing whether the object is studying us peacefully, assessing us neutrally, or targeting us hostilely. Living with ambiguity, wondering what's coming, unable to prepare because we don't know what we're preparing for. Or, most likely by far, it's just a comet. Natural ice and rock from another star system, wandered into our neighborhood by chance. All the anomalies have boring natural explanations. Dark forest is irrelevant because no one's out there watching. We're alone. Our broadcasts disappear into empty void. No response because there's no one to respond. The silence continues. The mystery remains, but for different reasons. Not because everyone's hiding, but because there's no one hiding. Just us and the physics and the vast empty spaces between stars where nothing thinks or watches or cares what we do. Which interpretation is correct? We'll know more soon. Days until perihelion. Weeks until re-emergence. The object crosses the threshold, hidden from view, doing whatever it does when no one's watching. And we wait, wonder, prepare or don't prepare, hope or worry, because the universe keeps its secrets until it's ready to reveal them. And revelation, when it comes, might be comfort or catastrophe or something stranger than we've imagined. The answer approaches. Time will tell. October 29th, 2025. Mark it on your calendar. Circle it in red. This is the date when 3I Atlas reaches perihelion, its closest approach to the Sun, 1.4 astronomical units out, just inside Mars's orbit. For a comet, this is the moment of maximum stress, maximum heat, maximum activity. Solar radiation at this distance is intense enough to vaporize ice rapidly, to crack rock from thermal expansion, to potentially tear apart any object that isn't structurally sound. Some comets survive perihelion intact. Many don't. The archives contain dozens of objects that approached the Sun and simply disintegrated, never seen again except as expanding clouds of debris. Will 3I Atlas survive? Given its apparent mass, its structural integrity observed so far, probably yes. Complete disintegration seems unlikely, but survival doesn't guarantee unchanged. Fragments could break off. The spin rate could alter. Surface layers might crack away, revealing different materials underneath. Outgassing could intensify dramatically, creating spectacular brightness increase visible even from Earth. This is nature's stress test, the crucible where we learn what 3I Atlas is actually made of, whether it's solid rock, loose rubble pile, pristine ice, or something else entirely. Except we won't be watching when it happens. The geometry betrays us. On October 29th, 3I Atlas will be directly behind the Sun as viewed from Earth, hidden in the solar glare. No ground telescope can point at the Sun and expect to see a dim comet right next to the solar disk. The brightness ratio is impossibly large. You'd burn out the instrument before detecting anything useful. Even space telescopes face enormous challenges. Scattered light from the Sun creates a huge zone of sky that's effectively unobservable. 3I Atlas will be deep in that zone, invisible, for weeks. The blackout isn't brief. The object approaches perihelion through late October, reaches closest point on the 29th, then slowly emerges from behind the Sun through November. Not until early December will it clear the solar glare enough for Earth-based telescopes to acquire it again. More than a month of blindness during the most critical phase of its journey. Whatever happens at perihelion will be over. By the time we can see the object again, we'll observe only aftermath, changed trajectory, altered brightness, new structure, possibly fragments. But the moment itself, hidden. Avi Loeb points this out repeatedly in his blog posts and interviews. The timing could be intentional. If you wanted to do something unobserved, this is exactly when you do it. Behind the Sun, shielded from Earth-based observation, with weeks to act before emerging into view again. For a natural comet, timing is coincidental and meaningless. Comets don't choose their orbits. Physics determines their paths billions of years in advance. But for an artificial object, for a probe following a planned mission profile, the hidden perihelion offers perfect operational security. Execute maneuvers during the blackout. Deploy equipment when no one can watch. By the time you're visible again, whatever you did is done, and observers can only infer events from forensic examination of the aftermath. We're not completely blind. Some instruments might catch glimpses. Parker's solar probe orbits closer to the Sun than any human-made object, diving through the corona repeatedly to study solar wind and magnetic fields. It's not designed for comet observation, but it's positioned near the action. If 3I Atlas does something dramatic, brightens enormously, or fragments spectacularly, Parker might see. The data would be partial, not optimized for this purpose, but better than nothing. SOHO, the Solar and Heliospheric Observatory, watches the Sun continuously from a gravitationally stable point between Earth and Sun. Its coronagraphs can detect objects near the solar disk. Dozens of sun-grazing comets have been discovered in SOHO imagery, often by amateur astronomers reviewing publicly released data. If 3i Atlas changes appearance significantly, if it brightens or breaks apart, SOHO should capture evidence. Stereo spacecraft provide different viewing angles, positioned in Earth's orbit, but ahead and behind our planet. Together with Earth-based instruments, they enable triangulation, three-dimensional positioning of objects near the Sun. Between these various platforms, we'll piece together parts of the story. But the observations will be peripheral, incomplete, lacking the detail we'd get from dedicated telescopes tracking continuously. Hints rather than proof. Suggestions rather than certainty. Radio telescopes will be listening throughout. The Deep Space Network, NASA's global array of giant antennas, monitors space constantly. If 3i Atlas transmits, if it sends signals to deployed probes or back toward its origin star, we might detect them. The Galileo Project telescopes are also listening, specifically hoping to catch any artificial transmissions during this critical period. So far, 3i Atlas has maintained radio silence. No emissions detected at any frequency we're monitoring. But silence proves nothing. It might be listening rather than transmitting, or using communication methods we don't recognize, frequencies or modulations or protocols we're not equipped to detect, or simply maintaining operational security. No unnecessary signals that might reveal capabilities or intentions. December brings the reveal. Early in the month, 3i Atlas will clear the solar glare enough for ground-based observation. This is when truth emerges, or at least when we get more data. Within days, probably hours, observations will flood in from observatories worldwide. Professional astronomers have telescope time scheduled. Amateur astronomers are ready with equipment trained on the expected position. Everyone with capable instruments will be looking. The data will be immediate, public, uncontrollable. NASA can't embargo thousands of independent observers. If 3i Atlas looks different, if anything about it has changed, the world will know quickly. Compared to predictions, trajectory calculations are extraordinarily precise. We know exactly where 3i Atlas should be in December, based on gravity alone, accounting for solar radiation pressure and expected outgassing forces. Any deviation means something happened during the hidden period. Measure brightness. Compare to models. If it's much brighter, massive outgassing or surface changes occurred. If dimmer, material was lost, or surface properties changed. If multiple objects now exist where there was one, that's fragmentation, either natural breakup or deliberate deployment. Look for spectroscopic changes. The composition should match what we observed before perihelion, unless surface layers burned away, revealing different materials underneath. Check the spin rate and orientation. If it's tumbling differently, internal structure changed or momentum was transferred somehow. Every observable property gets compared to predictions. Deviations demand explanation. Small differences might be natural thermal effects. Large differences suggest something more interesting happened during the blackout. The search for mini-probes begins if Loeb's hypothesis has any merit. Objects deployed during perihelion would be heading toward planets now, too small and dark to see from Earth at distance, but potentially detectable as they approach. How would we find them? Asteroid surveys like Atlas scan the sky every night looking for moving objects. Anything large enough and reflective enough shows up eventually. But large enough is relative. Something a meter across at astronomical unit distances? nearly impossible to detect unless you know exactly where to look. The search becomes needle in cosmic haystack unless the probes are obvious, bright, or transmitting. Anomalous phenomena might increase. If probes enter Earth's atmosphere or operate in our vicinity, we'd see them as UAPs. Commercial pilots might report more unknowns. Military radar could track more objects that don't match known aircraft or satellites. The Pentagon's UAP office, which already acknowledges detecting phenomena it can't explain, might get busier. A pattern might emerge. After 3I Atlas perihelion, sudden spike in reports. Could be coincidental, attention bias making people notice things they'd normally ignore. Or could be causal, actual objects arriving from the interstellar visitor, operating in our airspace, studying Earth directly. Radio emissions become key indicator. If deployed probes communicate with each other, or back to 3I Atlas, or toward their origin star, we might intercept those signals. SETI listening stations are alert. Galileo project monitors continuously. Any unusual transmissions get noted, analyzed, correlated with 3I Atlas's position, and predicted probe trajectories. Finding a signal doesn't automatically prove artificial origin, could be natural astrophysical source, but it raises the probability significantly and demands immediate follow-up. Direct observation remains the goal. Space telescopes like James Webb could be tasked to look for specific objects if we have approximate positions. But space is vast. Searching without good targeting coordinates is futile. We need either to get lucky, have something pass close enough to be obvious, or have the objects reveal themselves intentionally through transmission or reflected sunlight. Detection is hard if stealth is the goal. We might never find them until they want to be found, or until they do something that reveals their presence inadvertently. Realistically, if many probes were deployed and designed for covert observation, we probably won't detect them in December or even throughout 2026. They could operate for years before we notice, slowly approaching, studying from a distance, staying below our detection thresholds. Only when they get close to planets, when they interact with our satellites or enter atmosphere, would we have chances at detection. This makes the search both urgent and frustrating. Urgent because if something's approaching Earth, we want maximum warning. Frustrating because looking for small dark objects in vast space with limited resources is nearly impossible without breaks or clues. Longer-term implications extend beyond immediate December observations. 3I Atlas marks a transition point regardless of what it actually is. We're entering an era of regular interstellar visitor detection. The Vera Rubin Observatory, scheduled to begin full operations soon, will revolutionize asteroid and comet surveys. It'll scan the entire visible sky every few nights, detecting everything that moves. Projections suggest it'll find interstellar objects monthly, possibly weekly. Within a decade, we'll have dozens or hundreds cataloged. This transforms our understanding from extremely rare to common enough to study statistically. If most of those future visitors are clearly natural, straightforward comets and asteroids showing no anomalies, then 3I Atlas becomes an outlier. Interesting, but not paradigm shifting. 2 weird objects among 50 normal ones is just the tail of the distribution. Statistical variation that looks significant in small samples, but means nothing in aggregate. If most interstellar objects are boring, we relax. The universe is comprehensible. Physics works as expected. We're alone, but that's okay. Science proceeds normally. But if many interstellar visitors show anomalies, if strange trajectories and unexplained accelerations and unusual compositions are common rather than exceptional, that changes everything. Either our astrophysics is more incomplete than we thought, natural processes create diversity we don't understand, or the galaxy is more populated with artificial objects than we've assumed. Probes from various civilizations, some ancient and dormant, others active and observing. If 1 in 5 detected interstellar objects shows potential technological signatures, we can't dismiss them all. Pattern becomes undeniable. Investigation becomes mandatory. Intercept missions become priority. Next time an interstellar visitor is detected with sufficient warning, we launch. Spacecraft already exist in conceptual design phase, ready to be built if funding and mission profile materialize. ESA's Comet Interceptor is explicitly designed for fast response to targets of opportunity. Launch it toward Lagrange Point, park it there until interesting object appears, then redirect for intercept. With 3i Atlas, we had the warning, but not the spacecraft ready. Next time, we might. Close-up observation, sample collection, detailed imaging that resolves surface features, chemical analysis, all become possible with dedicated mission. Policy development needs to happen now regardless of December's outcome. We need international protocols for anomalous objects. Who investigates? Who coordinates scientific assessment? Who decides when military or security agencies should be involved versus when it remains purely scientific matter? How is the public informed? What level of anomaly triggers heightened concern versus dismissal as natural? These questions have no current answers. Different nations would handle the situation differently. No unified human response protocol exists. 3i Atlas exposed this gap. Time to fill it before the next visitor arrives. Technology advancement becomes justified if there's even small probability of artificial visitors. Better sensors, better coverage, space-based detection networks that monitor entire solar system continuously, not just from Earth's perspective, not just for security, though that's one motivation, for knowledge. We can't study what we can't see. The universe is full of objects and phenomena we're missing simply because we're not looking in the right places with the right instruments. Private sector might lead here. Galileo project model, funded by interested donors rather than government budgets, more agile, less political, able to pursue controversial research without career risk. Philosophical shift happens regardless of whether 3i Atlas is natural or artificial. Even natural interstellar visitors remind us we're embedded in galactic context. Material from other star systems passes through regularly. We're not isolated, not alone, even if we're the only intelligence. The galaxy is dynamic, full of wandering objects, carrying information about distant places and ancient times. Each visitor is a messenger, natural or artificial, bearing news from beyond. This expands our horizon beyond the solar system into larger cosmic community of matter and motion and deep time. The countdown continues. Days until perihelion, weeks until reemergence. Whatever happens behind the sun will happen. We'll see the results in December. Compare predictions to observations. Adjust probabilities based on evidence. If 3i Atlas emerges looking exactly as expected, natural comet hypothesis strengthens enormously. Most researchers will consider the matter settled. If it emerges changed, trajectory altered, multiple objects where there was one, questions multiply. Investigation intensifies. The debate that seemed academic becomes practical. We'll need answers quickly because something real is happening. Not just theoretical speculation about possibilities. For now, we watch the approach, track the object as it dives toward the sun, monitor what we can from Parker and Soho and stereo. Listen with radio telescopes, hoping to catch transmissions if any occur. and prepare for December, for the moment when 3i Atlas returns to visibility, when we finally see what perihelion did to it, what it did during perihelion, and what that means for our understanding of what's possible, what's real, and what might be approaching in the darkness between stars where we can't yet see. For most of human history, we assumed we were alone, not just in the sense that we hadn't met anyone else, but in the deeper sense that we were all there was. The universe existed for us. Earth was the center. The stars were lights placed in the firmament for our benefit. We were special, unique, the point of creation. Then Copernicus and Galileo showed us Earth orbits the sun. Then we learned the sun is one star among billions. Then we discovered our galaxy is one among billions. The scale expanded exponentially. The universe grew incomprehensibly vast. And throughout this expansion, we remained alone. The only life we knew. The only intelligence we'd encountered. Ourselves. This cosmic loneliness shaped everything. Philosophy, religion, art, all developed in a universe where humanity stood singular. We asked questions about meaning and purpose without reference to anyone else asking similar questions light years away. We were exceptional by default, because we were the only example. But we also hoped, wondered, looked at those distant stars and asked the oldest question, is anyone out there? Are we truly alone in all this vastness? Or are there others like us, or unlike us, wondering the same things looking back? SETI was founded on this hope, the search for extraterrestrial intelligence, listening for signals, decades of patient observation. Radio telescopes pointed at promising stars, monitoring frequencies where artificial transmissions might appear. Years became decades. Decades became half a century. Silence. Nothing but cosmic static. Natural emissions from pulsars and quasars and nebulae. No patterns suggesting intelligence. No messages. No contact. Maybe we are alone after all, people began to think. Maybe life is so rare, intelligence so unlikely, that we're the only ones in the observable universe. The loneliness deepened. Then October 19th, 2017. Oumuamua, the first confirmed interstellar visitor. Strange enough to make people wonder. Unusual enough that serious scientists proposed artificial origin. Probably natural, most concluded. But the question was raised. The possibility was considered. The certainty of loneliness cracked slightly. Maybe we're not definitively alone. Maybe just probably alone. Different feeling entirely. Now 3i Atlas, larger, stranger, more puzzling. Whether it's artificial or not, whether it's probe or comet, the question is being asked louder, with more urgency, with better data. We now live in a universe where alien visitors are possible, where objects from other stars pass through our neighborhood, carrying who knows what. This changes the feeling of looking at the night sky. Those aren't just distant lights anymore. They're potential homes to others, to civilizations that might be looking back, that might have sent explorers, probes, messages, that might know we're here. The maybe matters. The uncertainty transforms everything. Even if 3i Atlas is natural, even if all future interstellar visitors turn out to be natural, we've crossed a threshold. We're no longer certain we're alone, just uncertain whether anyone else exists. That's profound difference. Changes how we think about ourselves, our place, our future. We're potentially in conversation with cosmos, even if no one's answered yet. The possibility remains open. Hope persists. And with hope comes both excitement and fear. The government trust problem revealed by 3i Atlas matters beyond this specific object. The pattern of selective disclosure, rushed reassurances without supporting data, missing images from critical observations. All this breeds skepticism, not about science itself, but about transparency, about whether authorities tell us what we need to know or what they want us to believe. This isn't unique to NASA. Same pattern appears repeatedly across institutions: climate data, public health crises, financial system risks. Anywhere information gets managed by gatekeepers who decide what the public can handle. Trust erodes when information feels controlled, when we can't see raw data, when experts behind closed doors decide what we should know. We start wondering what they're hiding, even when they're hiding nothing. The appearance of secrecy damages credibility as much as actual secrecy does. With 3i Atlas specifically, the Mars flyby silence hurts. If images showed normal comet, why not release immediately? Confirming official story should be easy, reassuring, trust-building, unless images showed something else, something ambiguous, something requiring careful interpretation and contextualization before public release. Then delay makes sense operationally, but looks suspicious optically. The result: conspiracy theories thrive, not because people are irrational, but because institutions act in ways that invite suspicion. Caution appears as cover-up. Thoroughness looks like stalling. And the gap between what's known internally and what's shared publicly becomes space where speculation grows wild. Breaking this pattern requires radical transparency. Release data immediately, even if interpretation is uncertain. Trust public to handle ambiguity. Accept that confusion in the short term builds credibility in the long term. But institutions resist this. Too risky, too chaotic. Better to control narrative even at cost of trust. Imagine 3i Atlas is confirmed artificial. Not probably, not maybe, but definitely. Trajectory changes that can't be natural. Radio transmissions detected. Probes deploy and we capture them on camera. Undeniable evidence of technology from beyond Earth. What happens then? This would be paradigm shift, comparable to Copernican revolution or Darwin's evolution. Fundamental restructuring of how we see ourselves and our place in universe. Religions would respond variously. Some theologies exclude alien life explicitly or implicitly. Others embrace it easily, incorporating new discovery into existing frameworks about God's creation being vast and diverse. But specifics matter. Do aliens have souls? Did they fall from grace or remain sinless? Do they need salvation through Christ, or do they have their own path to divine relationship? These aren't just academic theology questions. They're practical pastoral concerns affecting billions of believers. Some would experience crisis of faith. Others would feel their faith confirmed and expanded. Religious institutions would face pressure to provide answers quickly, even when answers require decades of theological development. Governments would need coordinated response. Can't have competing national strategies for species-level contact. International cooperation becomes instantly critical. United Nations takes on new importance as the only body representing humanity collectively. Or, new institutions form specifically for extraterrestrial relations. Space defense coordination, contact protocols, information sharing, all require global frameworks that don't currently exist. Creating them under pressure, after confirmation rather than before, means hasty decisions and potential conflicts. Economies would react dramatically. Stock markets would fluctuate wildly in short term. Some sectors crash overnight. Traditional energy if aliens offer advanced power systems. Defense industries, if technology gaps make human weapons obsolete or irrelevant. Pharmaceutical companies, if alien biology or medicine suggests revolutionary treatments. Other sectors boom immediately. Communications companies expecting demand for systems that can talk to aliens or analyze their signals. Transportation, if new propulsion becomes possible. Materials science, if alien substances or construction methods become available. Long-term economic effects are unpredictable. Depends entirely on nature of contact. Friendly exchange of knowledge and technology could transform civilization within generation, solving energy crisis, disease, maybe even mortality. Hostile encounter means everything changes toward survival mode, mobilization, defense spending, possibly discovering our technology is hopelessly inadequate. Neutral observation from a distance means uncertainty persists. Markets remain volatile. No one knows what's coming or how to prepare. Uncertainty might be more economically damaging than either extreme because you can't plan for unknown unknowns. Individuals respond across spectrum, some with fear, existential dread, sense that humanity is now vulnerable to forces beyond our control or understanding. Sleep badly, worry about what comes next, prepare for worst-case scenarios. Others with excitement, sense of wonder, feeling that we're witnessing most important moment in human history. Privilege to be alive when first contact happens. Opportunity rather than threat, many with denial, insisting it must be hoax, misinterpretation, mistake. Can't be real, can't accept such fundamental revision of reality. Cognitive dissonance too severe, most with confusion. What does this mean for me? For my family? For my job and plans and future? How do I process this? What am I supposed to do with this information? Let's be honest about probability. What are actual chances 3I Atlas is artificial? Avi Loeb says 30 to 40% based on his scale rating of 4. Most scientists say less than 1%. Conservative estimate, maybe 5 to 10% chance after accounting for all anomalies. Not high enough to claim certainty. High enough to investigate seriously. Not dismiss out of hand. Bayesian reasoning suggests starting with low prior probability that alien probes visit us, because that's rare even if aliens exist. Then update based on evidence. 7 anomalies, each unlikely. Collectively, they raise probability, but don't push it above 50%. Result: more likely natural than artificial, but possibility can't be ruled out. Worth watching, worth preparing for, worth taking seriously, even if skeptical. This uncertainty is uncomfortable. We like definite answers, like clear categories, natural or artificial, safe or dangerous, known or unknown. But reality doesn't cooperate. 3I Atlas exists in gray area. Evidence points both directions. Explanations remain provisional. We might never have final answer, might need to live with ambiguity indefinitely. Object could leave solar system without settling the question. December observations might clarify some things while leaving others mysterious. This is normal in science. Most questions don't have final answers, just better and better approximations. More and more data, refined models, but never perfect certainty. Learning to live with this uncertainty is important skill, not just for 3I Atlas, but for existence generally. Universe is ambiguous. Data is always incomplete. We make decisions under uncertainty constantly. This object just makes the uncertainty more visible, more significant, harder to ignore. Whether it's rocket, whether it's natural debris or alien probe, we're forced to confront how little we actually know, how much we assume, how fragile our certainty is when examined closely. The value isn't just in the answer, it's in the asking, in pushing boundaries, in refusing to assume, in staying curious. 3I Atlas made us think, made us question, made us look up and wonder in ways we hadn't for years. That's worth something, maybe worth everything, because humans who wonder, who question, who refuse easy answers, those are humans who grow, who learn, who eventually figure things out, even if it takes time. Step back and look at larger context. We're living through extraordinary time. Detection technology improving exponentially. James Webb sees unprecedented detail. Ground surveys find thousands of objects monthly. AI analyzes data faster than humans can review. We're finally able to see what's really out there. And it's weirder than expected. Thousands of exoplanets discovered. Some in habitable zones, some possibly showing biosignatures. Fast radio bursts, mysterious and repeating, origin unknown. Black hole imaging achieved for first time. Quantum mechanics getting stranger and more verified. Universe expanding faster than models predict. Dark matter, dark energy, most of cosmos unknown to us. In this context, 3I Atlas is one piece of a larger puzzle, one data point in broader pattern. We're learning universe is more complex, more surprising, more populated than we imagined. Whether this specific object is natural or artificial matters less than broader realization. We're at beginning of understanding, not end. Discoveries ahead dwarf what we know now. 3I Atlas might be first confirmed alien artifact or unusual natural comet. Either way, it's a reminder of how much we don't know, how much we have to learn, how exciting future might be if we keep looking, keep questioning, keep wondering what's out there in the dark. So what is 3I Atlas actually? Honest answer, we don't know yet. Ask again in December, after perihelion, after reemergence, after detailed analysis of post-perihelion observations. Then we'll know more, probably not everything, but more. Is NASA hiding something? Maybe, maybe not. They're certainly cautious, careful about information release. Whether that's responsible science or deliberate obfuscation depends on perspective and what they actually know versus what they're sharing. Should we be worried about alien mothership? Probably not. Likelihood is low. Worth monitoring, worth preparing for just in case. But panic is premature. About government transparency? Yes. Information control is concerning regardless of content. Public has right to know, to see data, to make own judgments. Democratic societies require informed citizens. Secrecy corrodes that foundation even when motivated by good intentions. What should we do? Watch December. Telescopes are ready. Amateur and professional. Anyone can observe. Anyone can analyze public data. Truth will emerge one way or another. Stay curious. Question everything. Authorities, experts, media, but also your own biases. Confirmation bias works both ways. Believers see what they want. So do skeptics. Try for objectivity, even though it's hard. Keep perspective. This is one object, one moment. Universe is vast. Mysteries are many. 3I Atlas is fascinating, but not everything. It's a beginning of longer story, one we're all part of, one that's just starting. The age of interstellar visitors is upon us. They're coming regularly now, whether natural or artificial, whether carrying messages or just carrying ancient ice. They're arriving, and we'll be ready, or we won't. Either way, it's going to be interesting, challenging, transformative, because whether we're alone or not, whether we're being watched or not, we're no longer certain, and uncertainty changes everything. Picture. December night. You look up, find 3I Atlas and telescope. Small point of light moving against stars. What do you see? Ancient comet, billions of years old. Ice and rock from alien sun, natural but remarkable. Or something else? Construction of intelligence, sent to study us, carrying sensors, memories, purpose unknown? Either way, it's out there, right now, approaching the sun, about to undergo transformation, about to tell us something about universe and our place in it. Until then, we wait, we watch, we wonder. What is 3i Atlas? The question echoes through dark spaces between stars where answers hide, patient and silent, waiting for us to find them, or for them to find us. The universe holds its secrets for now, but December is coming, and with it, revelation or disappointment. Truth or continued mystery. We'll see. Together, under same night sky, looking up, asking why, and waiting for the answer to arrive. Riding on a beam of ancient starlight, crossing the void between possibility and proof, between what we hope and what we fear, between the universe as we understand it and the universe as it actually is, vast and strange and full of wonders we're only beginning to glimpse.